All right. Hello, everyone. I think everyone is starting to shuffle in. That's good. If you would like, you can go ahead and do introductions in the chat. I'm going to make sure we start right at 1 o'clock, um, before everything gets started. So yeah, 1 o'clock, about 2 more minutes before we get started. Again, for everyone that is joining us, we'll get started promptly at 1 o'clock. If you would like to, please go ahead and introduce yourselves in the chat, before we get started. Thank you. And then I see we have one additional panelist also listed as A. Donnelly. Dennis, is that someone with you that's also helping co-present?
Uh, no, Ashley was going to present, but she's out traveling, so it's just me on my end.
Just
It's
you. Okay.
Curtis. It's
Oh,
Curtis.
oh,
Oh, sorry,
hi.
Yeah,
Curtis is here. Curtis is here as well. Yeah,
I'm acting as Ashley today.
there you go. Thanks, Curtis.
Okay. Curtis, are you
uh,
presenting today too? Or just
I, I'm literally listening in. I'm the Illinois rep that actually is
okay.
on the ground out there all the time. So if there's anything I can answer, I'm happy to pipe in.
Okay,
So
great, great. I just want to make sure I'm
gotcha.
not forgetting anyone. Don't
No,
want to
you
forget
can
anyone.
you can call me Ashley too. I'm fine with that. It'll be fine. So
No, it's fine. That is okay. All right. So
I
it
figured
is.
I better pipe up before you kick me off. So
No, you're fine. It's okay. It's all good. So with that being said, it is 1 o'clock. So Lenore, if you wanted to go ahead and take over and do introduction.
Wait. Hmm. Thank you. For those of you who don't know me, I am Lenore Killam. I am the interim president of the Illinois Environmental Health Association. And I have a few announcements at the beginning and a couple of announcements at the end. I'm so pleased everyone is joining us today. This spring virtual conference has been quite successful and well attended, and I look forward to some good learning. First announcement is to save the date for the Illinois Environmental Health Association Annual Education Conference, and that will be held at Starved Rock Lodge on the 3rd and 4th of November. So the first week of November. Also, we need speakers for the annual conference, and look for a call for abstracts. You will receive that this summer. And the third announcement rather, elections will be opening soon for our board of directors. And we will have president-elect, treasurer, North, Central, and South chapter directors, and the director at large until 2029. All of those positions are open. And the board is, it's very difficult to explain how well we function and how enjoyable it is. So please consider joining us. And fourth, congratulations to Justin Dwyer, who last year gave the announcements. He has a new position as National Environmental Health Association Region 6 Regional Vice President. So I am taking over those responsibilities to chair host the conference today. With that, take it away.
All right, thank you so much. And then I apologize. I don't know if I introduced myself on last Tuesday or this past Tuesday. My name is Arne Burns. I'm the Health Education and Training Specialist with IPHA, and I'm just helping to kind of host our spring virtual conference here. But I don't want to delay any further. I'm going to go ahead and turn it over to our first speaker for today, Dennis Hallahan, whose topic will be from conventional to combined dispersal. Overview, what and when to use in Illinois. So Dennis, whenever you want to share your screen and you can go ahead and get started.
Okay, let me know if you can see that.
Yes, I can see.
Okay. Hello, everybody. Again, my name is Dennis Hallahan. I work for a company called Infiltrator. Some of you may have heard of us. And also on the line here, we have Curtis Clucky, who is our local area sales representative, who is very, very familiar with the rules and regulations in Illinois, and boots on the ground type of thing with soils and everything else. So we're happy to have him on board as well. So I'll jump right into the presentation here. If I can figure this. There we are. Okay, a little bit about me. I'm a professional engineer with over 35 years of experience in the decentralized wastewater industry, actively involved with the industry. I serve on boards and author papers and research, and hold a couple patents with Infiltrator. So that's been great for me. So I want to talk to you today about EasyFlow. Many of you in environmental health have, I guess environmental health covers a lot of different areas, such as food, such as body art and everything else. One of the areas a lot of you may focus on is on-site wastewater and septic systems. So that's what I'm here to talk to you about today. EasyFlow is a product that's installed as a drain field product in the field. It's been in use for over 38 years. It's made of a recycled material and first approved in Illinois back in 2008. I hope some of you have had some experience with this. In general, in the industry, both on the contracting side, the installers, the designers, and the regulatory side, we have what's called the silver tsunami. It means, folks like myself getting older. There's a lot of retirement going on in the industry, certainly, during COVID, and now after that, it's continuing. So there's a lot of younger folks in our industry who need this training, who may not have seen this before. So I hope it really helps for you to understand what's going on and why. So what is EasyFlow? EasyFlow is what we call an engineered aggregate substitution. So it's approved for drain fields in Illinois as an aggregate substitute. So here you see on the right-hand side the EasyFlow aggregate. A lot of people will call it packing peanuts type of thing. It's polystyrene, but it's not like packing peanuts at all. It's specifically engineered for the use in mind. What does that mean? Well, it's engineered. This is called the double E, upside down and right side up. The double E configuration here, the shape of it. So that does a couple of things. It increases surface area and it increases the porosity, the open area, the open volume storage in the drain field. So it has more storage capacity than regular aggregate, the conventional aggregate used in the drain field. So this is a way we can ensure consistency and uniformity for an engineered aggregate out in the field as a substitute. A lot of people say, hey, how does that product, that material perform in a wastewater environment? Well, it does very well. It's what we call inert. It's not affected by wastewater characteristics and that sort of thing. So there's an assessment on that. And EasyFlow is IAPMO certified. What does that mean? Many states, you can imagine a company, a manufacturer such as Infiltrator, we have to get approvals in every state for every product. And many states rely on the UPC, Uniform Plumbing Code. So how do you get in the Uniform Plumbing Code? You get IAPMO certified and tested, then you can be accepted into UPC. So it's just another item for you to say, okay, hey, this product is well known, accepted, and used. And what you're looking at in this trench is what we call EasyFlow 1203H-GO. So this is what you're going to see in most installations for EasyFlow in Illinois. What does this mean, 1203H? Well, it's a 12-inch bundle, so it's a 12-inch diameter. It's three of them. H is horizontal, so 1, 2, 3. The center bundle has the pipe for the wastewater to enter from the septic tank or distribution box. It then falls to the trench bottom and disperses throughout the whole trench, and that water level rises over time. Everything has a design life. Most septic systems average will say a 20-year design life. So over the course of 20 years, this system will be full with water. Okay, the -GO, you can see the fabric on the top of the bundles. So this just gets installed as is. The fabric is included, the geotextile. You just throw dirt right on top of this, and you're ready to go. All right. So just a little background there on the EasyFlow. Again, so this is what you may seen or may have been typical if you're older in the business or been around a while, but it's really becoming less and less common. The chambers and or EasyFlow are now becoming what we call conventional technology. You're going to see those more and more being installed out in the drain fields, and I'll show you some reasons why. Here's some of the reasons. And so if you're a contractor, you don't have to haul truckloads and truckloads of gravel to the site. You don't have to wait for the truckloads. Think of the environmental impact of this mining site, right? The crushing, the mining, the hauling, the larger carbon footprint, and the environmental impact of that. So we can pretty much remove that with an engineered product such as the engineered aggregate EasyFlow. Structurally, how does it perform? Very, very well. Once the product is installed in the trench or a bed format and it's backfilled, here you see a minimum cover of, I shouldn't say a minimum cover, but a cover of 12 inches to meet what we call H10 loading. H10 loading is 16,000 pounds per axle. Okay, what is that? Well, a car would be about 3,000 to 4,000 pounds in total. So that gets spread among two axles. So you can see this has a large factor of safety. And I like to tell everyone, the worst day structurally your septic system is going to see is installation. The installation that's kind of become the standard now is an H10 load rating I talked about with 12 inches of cover for the product. That's become a standard now nationally that Infiltrator has implemented and many states have adopted. And so when I say the worst day it's going to see is the day of installation, think of a rubber tire backhoe, two axles. It's got a bucket on the front and the excavator on the back, and they're driving around. So that represents a significant point load. So when they install it and backfill it and grade it for that day, again, that's the worst it's going to see in most cases. So that's what these systems are designed to withstand. During installation with 12 inches of cover, you can drive whatever you want over it and then cover it up and get the grass to grow and you're good to go. So occasionally, let's say system was installed next to your driveway, but it's Thanksgiving and everyone's coming over, they're going to park on the lawn. That's not a big deal. We don't worry about that. We're not saying it's commercial under a parking lot and tractor trailers are driving over it. No, we're saying it's okay for occasional traffic off to the side of the driveway, no problem with a minimum of 12 inches of cover. So please enter any questions you have, and we're going to address them. I should say enter any questions you have into the chat, and we'll address them at the end of the talk. So please don't be afraid to put in any questions. Okay, so Easy flow is improved in what we call a reduction. A reduction compared to what? It's compared to the old gravel and pipe systems. So how does that happen? Well, basically, the old system, as you'll see, is very, very ineffective. It was what they had at the time uh, to make things work. But now, with the advent of chambers and easy flow and other products out there, it really doesn't need to happen. So what they found was that the stone, it contained compaction, embedment, and fines. So what does compaction mean? Well, the contractor excavates a trench and then dumps the stone. So when that stone comes entering down into the trench under force, and boom, it hits the bottom of the trench, it becomes embedded into the soil structure. So that's one negative. And the compaction it also causes when it gets dumped into the trench. And then here you can see all the fines. So if we can eliminate those three things, compaction, embedment, and fines, and if we just had an open soil interface with easy flow on it, we're going to provide a much better infiltrative surface. So that's the real reason, plain and simple. So the science has shown if we have two different surfaces, one with, let's say, easy flow on it and one with stone that has embedment, compaction, and fines, you're going to find two different throughput rates. So basically, the easy flow soil interface is going to allow more wastewater to pass through it because, again, it doesn't have any of these factors. So that's kind of the science behind it, so you know where it came from. We can do more in a lesser footprint because, again, the aggregate system is just really inefficient. So Infiltrator is a company. The Easy Flow is manufactured out of recycled materials, as well as the chambers, as well as the tanks. So we recycle over 100 million pounds of plastic every year. It's quite amazing what we do. So we're one of the top recyclers now in the nation, just as a wastewater products company. Easy flow installation, very similar to conventional systems, right? Stake out your system, where it's going, excavate the trench down to the design trench bottom elevation. Ideally, we like to keep them shallow. Shallower is better, but if there's better soils down deep, meaning more permeable soils, that's fine. But you'll find most cases in Illinois higher groundwater tables, so typically they're installed pretty shallow. But you're going to excavate the trench, check the trench bottom to make sure it's level. So the contractor will shoot the elevations, and it may step down the hill as you see here, but hand rake the bottom and then install the product. So very, very easy to inspect for systems. For example, these bundles are 10-foot sections. So if you had 3 trenches that are 100 feet long, you just count up the number of bundles, and if you have 10 bundles, it's 100 feet. Easy to check trench bottom. You can just hit the tops of the easy flow with the level, the rod, and check that. So very, very easy to install. No different than conventional systems. As I like to say, all these systems, whether it be stone and pipe, whether it be other products, it be easy flow or chambers, they're all soils-based systems. So the soils are what's important. We must protect the soils as much as possible. Here you see good soils, not smeared, not too overly wet, not coming out in big clods. Very good conditions, dry conditions. So make sure the soil on the bottom of the trench is the same. Hand rake it before it gets installed. And this just gets pushed right back in the trench. I always think it's interesting, look at this picture. Look at these roots here. Where are these roots coming from? Big roots. Everyone says, oh, roots are a problem in drain fields. And I'll show you some other pictures as we go along and we look at it here, okay? Fittings. So this is just a simple coupler here that couples the two bundles together, that center bundle that has the pipe. They snap together easily. This is the end cap for the end of the line. And this is where you connect to the wastewater coming into the trench. So let's say this is the pipe coming from the septic tank or coming from the D box. There's a coupler there that goes from the PVC pipe to our coupler over here that then connects into the 4-inch pipe in the bundle. So very, very simple snapping these things together out in the field. Here you can see contouring ability. Here you can see the ease of installation, right? No back and forth, back and forth, back and forth, dumping stone in the trench. And then the contractor has to hand rake the trench and then place in the 4-inch pipe. So he's going to place 6 inches of stone, place the pipe in, and then come back and place another 6 inches of stone. As fast as you're excavating, someone's checking the elevation of the trench and putting the product in the ground. So it goes very, very fast. Here's another example of trees. So what do you think trees have? Trees have roots, right? So are roots a problem in the drain field? I'll say no, they're not a problem. If anything, they're a benefit. They're helping to take up phosphorus and nitrogen and water. As Dr. Segrist said from the Colorado School of Mines, who was one of the wastewater gurus in the past, he would say to me, Dennis, we're taking wastewater, which is, water itself, which plants and roots love. But not only that, it has nitrogen and phosphorus, and we're placing it in the root zone. If you don't think roots are going to come in here, whether it's grass or trees or anything else, you're kidding yourself. Where roots can be a major problem is in sanitary sewers, right? Where it actually plugs the pipe and the pipe is physically going to back up. So roots would be a problem in our systems from the house to the septic tank, right? That's what we call a sanitary sewer. It's just carrying solids and liquids getting into the septic tank. So if roots got into that piping, that would be an issue. Out in the drain field, there's enough permeability and porosity where roots really are not too much of a problem. Are they every once in a while? Yes, with a very aggressive root or an invasive species, but for the most part, it wouldn't surprise me if we dig up systems and we find roots in many of them. So here's our typical installation in Illinois. Again, this is the 1203H-GO. The fabric is embedded within the product. It comes that way. You can see it here. The center pipe has a 4-inch pipe. The center bundle has a 4-inch pipe. And the rating in Illinois is 5 square feet per linear foot. All right. Also, these are very good systems for LPP, low pressure pipe. Here you see the main and the laterals coming off the main and a valve here at the front so we can dial this in. Here you see the pressure test coming into effect. They can measure the squirt height by the water level in that pipe. And if it's too high, they can turn this dial and this valve and lower the flow to this. So it helps to balance it out. This is especially really good if the sites are sloping to dial in those trenches to get equal flow. Nice system here. You can see very shallow, right? Only a couple inches of cover over that, and that'll be fine. We'll get a lot of evapotranspiration. We'll get root uptake of nitrogen and phosphorus. So a very nice system here. Trenches, you can see the center to center spacing. So this is a very nice site. Again, dry soils, you can see here. We can also have commercial systems. They just get installed bigger, right? So this is a system for a mine in Illinois that went in. Very, very big system. You'll see beds here. That's one of the many beds going in on the side of this slope here. And you can see we have different zones. A pressure pipe will hook up here and here. So this is a separate zone from this one. So you can turn some zones on and some zones off if there's issues going on. It allows for management of the wastewater. So we can do single family or we can design them for commercial systems. This is a splitter valve. When we said go into different zones, let's say the pump comes on, it's going to go to zone 1. Next time the pump shuts off, next time the pump comes on, it goes to zone 2. Then it goes to zone 3 and zone 4. So how is that done? It can be done a number of ways. One of it is solenoid valves. So that's electrically actuated valves, or you can have a splitter valve, a zone valve. These are called different things, but you can see the wastewater coming in from the pump and it goes to, let's say, zone 1. zone 2, zone 3, and zone 4. So they have up to 6-way splitter valves. These are hydraulically actuated, no electricity required. So some engineers like this, some engineers like to have electronically operated solenoid valves. So you may see some of each of these in the field. All right, mound applications. We do lots of mounds in Illinois because of the high groundwater. Easy Flow is very well suited for that. Here you can see the imported sand on below it. Easy Flow is put on top of the mound. The mound can be only 3 wide. It could be 12 wide. It could be 6 wide. So it's a function of the design. Here you see the pressure pipe, the LPP laterals inside the mound. When they pump up, it's going to distribute the effluent evenly throughout the length of the mound. When we're all done here, the contractor is going to cover this with soil and then cover it with topsoil as well and get a good grass cover over this type of system. All right, there's other applications for Easy Flow you may all see, so I just thought I'd bring them up quick. You can put Easy Flow behind retaining walls. It could be on the foundations. It could be an interceptor drain, or as we also call it, a French drain. And of course, the septic system itself. So in Illinois, we do have an approval to use Easy Flow for curtain drains, which are very common with on-site wastewater systems. If you have high groundwater, you can destroy the perimeter drain or curtain drains. Here you see one that's actually functioning. Here's it being installed. Here's it during a heavy downpour. You can see water just pouring out of it. So very, very effective with Easy Flow to absorb that groundwater, take it and move it out of the site. Because ideally we want our systems to be what? We want our systems to be high and dry to perform effectively. Okay, now I'm going to move into what we call CTD. Some of you may be familiar with this. So CTD, what's that? That's combined treatment and dispersal. Right, so we're going to have a look at that. Again, so it's combined treatment and dispersal. This is where, think of it as a modified proprietary sand filter. We can take this proprietary sand filter and put it anywhere. We can put it anywhere in the country now because it has a product, it has sand, and it goes on top of native soil. So let's just go through the different layers here. So the contractor will come and prep the native soil, install the system sand, a depth of 6 inches, put the product on top of it, and there's many products for this, what we call CTD systems. Backfill with sand around the system and put some cover over the top of that with soil, and then have a vegetative cover. So those are the layers we have, what we think of a CTD system. Testing on this. So this is actually approved as a treatment system. The CTD system is what we call NSF 40 certified. So this takes the place of a mechanical treatment system. If you're just looking for BOD and TSS treatment to NSF 40, this passive system will take care of that. So this provides treatment without any external energy. Again, it's all passive. No startup is required for seasonal use. It eliminates costly O&M, and it provides continuity during power outages, and it aligns with the UPC, the Uniform Plumbing Code. Here's some testing data. It was done in Canada, the BNQ. So basically with 6 inches of soil, when we apply the wastewater to the CTD system, it came out sub what we call 5.5. So BOD, TSS. This is CBOD and TSS. So less than 5.5. And that really tells you the benefits of this type of system. Very, very stable, very, very robust. If I were to ask everyone in the room, or if there was a bunch of engineers in the room, what do we need for wastewater treatment? What 2 factors do we need? We need oxygen and we need surface area, right? Those 2 factors. So the soil provides that for us. So I walk around, or I travel the country, and I tell people, look, the answer for wastewater treatment is right under our feet. Soil is a very, very effective treatment mechanism. All we're doing is taking the effluent. Effluent, think of it as organics. Organics is food. We're just feeding the bugs. The bugs being the microbes. Microbes are just sitting there waiting to be fed. We apply that wastewater to the soil, and the microbes just love it and they eat it and they consume it. So it does a great job for us. Now, the one thing NSF40 does not address or does not treat by design is nitrogen. If you're looking for nitrogen treatment, then we may go back to a mechanical treatment system with recirculation and other types of things. The NSF40 does not address nitrogen. So we're just looking at BOD and TSS for a higher level of treatment. So whether it be easy flow, whether it be a CTD system, again, many products there, other manufacturers, our stone and pipe system, all these systems are soils based. We still need to have a very, very thorough site evaluation. All right. So we need to know where that water table is. We need to know what the application rates of the soil. So we need to get the soil scientist out there and do a very thorough site evaluation. The design guidelines for AES are very simple. We size it based on 70 linear feet of pipe per bedroom. And then there's spacing, and we have the typical, I'll say, most states have a trench length maximum, most of them at 100 feet. So we put that as a limit, but other states we allow longer lengths if you'd like. Just like we say the recommended minimum length is 30, but there are some cases where we need to be less than 30 because it's a repair. And hey, Dennis, I got a backyard. It's a tight little backyard. I don't have 30 feet of width or length. I need to have a bunch of rows that are 20 feet long. Okay, fine. We're happy to do that. But ideally, somewhere between 30 and 100 is good. And then, of course, all the rows are installed level, but there's a tolerance as well. It doesn't need to be exactly level. Lots of system flexibility here as well. Just like easy flow, we can have curved systems to fit the site to get around trees or get around a utility box or whatever's there out in the field. Here's a great view of a cross section of the system. So this helps me explain it better how the system works. So with CTD, there's basically two design interfaces. The first interface is wastewater, so septic tank effluent, into the soil. So that's sizing is that 70 feet per bedroom. So that's 70 feet per bedroom for residential strength. If we're talking commercial, I would say get in touch with us because it's a higher strength effluent. So we may need, more trenches or lower the loading rate, or you could put advanced treatment in front of this. So for today's application, let's just talk residential strength. So this first interface again is household sanitary waste going through the pipe, coming out into the soil. So again, that's 70 feet per bedroom. Then what happens? The wastewater travels down through the soil and it gets treated. It hits this secondary boundary. So this is the boundary between the system sand and the native soil interface. So you can imagine if I have a soil that's native, that's very porous, like a granular soil, I don't need much interface here to make that go away. If it's clay, I have to expand my boundary here because it's basically now a clean water hitting the native soil. So a clay interface may have an application rate of 0.1 or 0.2 gallons per day per square foot, whereas the granular interface application rate may be 1 gallon per day per square foot. So this is based on the 70 feet per bedroom. This is based upon your native soil and your application rate. So this may grow or may shorten depending on your native soil. And of course, we need the separation distance maintained to the water table. So when we come out of here, again, we get great BOD and TSS removal rates. That's great. And then we pass down through the native soil until we hit the restrictive layer. So this distance here is going to get rid of what I call the bad guys. The bad guys are the viruses and pathogens, which get people sick. So This separation distance is always necessary to protect public health. All right, so lots of ways to lay out a CTD system. This is a serial system, so it comes in maybe from the D box or comes in from the septic tank directly, travels down the row, and comes back, row 2, and comes back again, row 3. This could all be also be set up as parallel. Come here with a T, or come here with a D box and go to each row. It's very, very flexible with design. Just to show the piping layout, you can see we're connecting into the ends, whether this be one big long pipe with a header pipe. This system happens to be serial distribution, which comes into this first pipe, again, from the septic tank or distribution box. It would travel down the length and come here and go down and come back and so forth. So serial distribution works just fine. We have no problems with it. We have a lot of history with it. Sloping with CTD has many benefits, where if we were to lay out a chamber trench system or a pipe and stone system, a bed system, we have to fill, and then come down on a 3-to-1 slope. So we have a lot of fill having to be brought in, a lot of site disturbance. Where the CTD system, we just lay it out at grade. We step these down, just like stepping trenches down a hillside. So it can be very effective with a small footprint and fit the site very, very well. Notice we show a vent here. CTD systems, at least for our products, infiltrator products in Illinois, do not require a vent. Yes, the designer or contractor can install one if he'd like to, but it's not required. Here you see a system on a slope. It really doesn't do it justice. This is very steep. You can see the stakes just to hold the product in while it's being installed. And on a slope, we definitely encourage serial distribution because things want to flow downhill. So this, you can see it's a serial distribution here. And here's the sand extension downhill, again, to meet that native soil interface application rate, the extension there. And there are components to the AES system, just like the Easy Flow system. We have couplers. The pipes come in 10-foot lengths. They're coupled together. We actually have a new coupler that's a little bit simpler and easier and faster to use now. But this is our older one, but you'll still see these out in the field until those all get used up. So very simple to attach the system together. Again, more layouts. What if we had multiple beds? Here we have a D box coming in, going to bed 1, going to bed number 2 and 3, and so forth. So you can imagine a large commercial system may need to look something like that. Here's a center feed. This is maybe a long, skinny lot. We can't be over 100 feet with any one trench. So let's come in the center. Let's go 100 feet one direction, 100 feet in the other direction, and that happens to fit the site. So I like to say, however you plumbed a system or designed a system for the layout, the CTD system can accommodate that as well. Another CTD system you may see in Illinois is ATL, that's Advanced Treatment Leach Field. I just want to mention it in case you do see it, but that's also out there. AES, meaning Advanced Enviroseptic System, is definitely more common. But I just want to mention you may also see ATL. Very, very similar, very common type of system. It follows all the same design guidelines. So installation, again, very simple. You're going to prep the site, assemble the system, and then, and I should say, install it, and then backfill, and then provide your site grading. So step number 1, what do? The contractor shows up, scrape all the organics from the dispersal area off to the side. This is it's really important. Where do we see most failures with this system? It's that native soil interface. Maybe it's compacted, maybe it's smeared. So however you prepare, let's say, a mound system, you till it in place. You have the chisel plow, or however you do it in your area, please do the same. So you're looking to provide an interface that's not smeared, that's not restrictive. And then mix in that system sand, sprinkle it, ladle it in, or push it in from the sides with the dozer pushing it in. Do not have the dump trucks drive over the system and dump on top of it, traveling over the system. Keep those dump trucks off. It's all about the soil. It's all about the soil. Okay. So we're going to loosen the receiving soil, that native soil interface, prep it nicely, and then place the system sand and level it. So by placing it, we're saying ladle it out there, scoop it and ladle it, or push it in from the side with tracked machinery. Again, we're looking for low impact to that soil interface, always looking to protect that native soil interface to do so. So here you see a nice site prepped up, scraped up, tilled in place, ready to go. That's a nice system prep we like to see. Here you see the system sand ready to be scooped and put into place. What do we mean by system sand? Well, there's a spec on it, and I'll show you that. We're looking for a clean, coarse sand, minimal amount of fines. Here you can see a much more uniform sand, lots of fines involved. Here's our system spec. We like to refer to ASTM C33, but there's a little bit of flexibility there. But this is a spec that is out there nationally, so we kind of latched onto it. But there's some flexibility here, just to let you know. Basically, allow 0 to, let's say, 6% passing on the number 200. But we want a clean, coarse sand. All right. There is a spec check available, so you can actually inspect the sand out in the field. We have instructions on that. We can train you on that. What's really, really great is if you do this once or twice out in the field and the contractor knows you're coming to check on it, you can guarantee that contractor is not going to cut corners with the sand. He's not going to use the cheap stuff and try and sneak it by you. If he knows you're coming out with this, and I'm not saying you have to use it every time, just do it every once in a while, then you'll keep that contractor in line. Yeah. So it's a great, great thing to have, or a nice tool to have in your car with you. Here you see a typical AES system going in. This happens to be a bed system. The end caps will go on. The contractors typically make some rough forms to hold it in place. So when they're ladling that backfill on top, the pipes don't move. There's a number of ways to do that, but those will get pulled out. Here you can see the system sand underneath. System looking nice, system looking good. Here you see the backfill ladled on top. What do we need for maintenance? Keep in mind, this is an NSF 40, right, treatment system. So there are other treatment systems. Hey, I have a blower. What do I do? How much sludge is in the tank? All those types of things. Well, there's really not much maintenance to do with this CTD system. It's really whatever you needed to do for a conventional system, because there's a septic tank involved. So the septic tank and drain field, the drain field just happens to be, I'll call it an optimized sand filter. So what do we need to do? Just check to make sure all the components are buried. No rodents have come in and dug holes, and there's no moisture on top of the field with soggy soils. Maybe the system was abused or something and grease got out and it's starting to pond. So you just gotta, walk the drain field and check it. Pump the septic tank on an as needed basis. And if there is a filter, pull the filter and clean it to maintain the filter. But that's really it. The same things you would do for a conventional system, you would do for the CTD system. Okay, so what does Infiltrator have for you to look at, to get training on? Certainly, you can always just call us and we'll take you through this. So don't feel like you have to memorize this, but go to our resource center. We have online certification training. We have some Illinois specific design manuals for both AES, ATL, and EasyFlow. So we have those design manuals available for you. And some states require we provide certification training, and then let's say the contractor has to take the test. I'm not sure what Illinois requires. Curtis may know, and he'll let us know. But we have that available for you.
Yeah, Dennis, we do require AES online certification. That way the guys get put onto a list. So if a county and or the state calls to request a list of certified installers for this product, we have it available. So they, even though I might go out on a job site and train someone, I still make them take the test online just so that we can get the certification in house. So,
Hey, that's great, Curtis. Thanks for jumping in. I told
sure.
you I deal with all USA and Canada, so I've long given up trying to
Yeah.
memorize every state's requirement. But we do have some great resources here. Here you can see how to get to the location specific manual, your resources. Click down on the location specific manual, and then you go to the Illinois. Uh, we do have a calculator. I'll show you that as well. But we have the installation manual, design and installation manual as well. So we do have a calculator, which is real simple. It's just glorified spreadsheet that makes it simple and easy, and it'll actually print out little or provide schematic drawings of the system, like, okay, this is 8 rows, 30 feet long, and that sort of thing. And then what the cross section would look like as well. We will always provide CAD details. If you said, hey, Dennis, here's my spreadsheet, but I want this on a plan. Can you get that to me? We're happy to do that for you. We have that service. So don't be afraid to call us. Okay, the whole point of the presentation was what to use when. So easy flow versus CTD. When would I use one over the other? Well, they're pretty basic and simple if we break it down. The easy flow is more a conventional system for conventional sites. If you have the space in the area, it's not a super tight site and you can fit it, it's probably your lower cost solution because you're not importing sand and that type of thing. So then you do use easy flow. When would I use CTD? Well, in the poor soils areas, if treatment is required, again, to NSF 40 standards, not with nitrogen reduction, and tighter lots. So those really the breakdown of when somebody would use it. Now, there is two other things added in here. There's both a designer preference and a contractor preference. Somebody may say, look, I just love CTD and I'm a designer. I'm going to specify it, or maybe the contractor loves it and he's all set up and his distributor and he gets, shipped truckloads right to his yard right from the distributor, and he wants to, he can, so they can do that. But so I just want to throw this in because sometimes some designers or contractors have preference of what they want to do. All right, so again, technical support and customer service, please visit us online. Free customer support for all the things I had talked to you about. These are our local contacts. This is Curtis's. He's on the line here with us, or on the conference right now. He's plugged in, so please feel free to write that down. In our office here, I'm happy to be in Connecticut at the corporate office. We have Pat Cole, who's our supportive representative. And then, of course, you have myself as well. And this is my contact information. So I want to turn it back to you, Arne. And any questions come in or anything I can help to ask, or for me and Curtis?
Yes.
Did this one,
Go
could I throw in one more comment? I'm sorry, I apologize. I didn't mean to hop in front of you. But one other thing that we're seeing a lot of use with the CTD is the water table issues we have in Illinois. We're dealing with that a lot. So we get a 12-inch vertical separation distance from the bottom of the sand to the limiting layer, where if we're in a conventional application, it's 2 feet. So that's another one of the bigger reasons why the sand-based CTD systems have kind of really taken off, is because of the issues Illinois has with their soils. So
that's a good point, Curtis. Thank you so much. So that is a significant benefit, that there's a separation distance reduction if you use the NSF 40 CTD treatment system. Thank you for bringing that up.
yeah. The last thing on the chambers and easy flow too that kind of gets missed now, and this is ADS chambers, it doesn't, whoever's chamber you're using, it doesn't matter, but we basically have 5-foot center to center spacing now across all of these product lines too in conventional applications. So now sometimes we can fit some of that on sites where before, when we had to be 9 or 10 foot between makes it pretty tough. So that's another kind of thing that happened back in 2019, I believe. That's been a big boon. So anyway.
Good point. So we're getting a smaller footprint there. We can fit, that same, let's say, three-bedroom system on a smaller footprint now with this 2019 approval with that 5-foot separation. So that's great to know.
Correct. I'm done now.
No, it's okay. It's okay. We do have a few questions. First one here, what kinds of plastics do you use in construction and where do you source them from?
So our plastics that we get supplied to us come from all over. I mean, all over the country, mostly in the Midwest, because our manufacturing plants are centrally located in Kentucky. But there's a lot of manufacturing with automotive industry that will get all sorts of things, bumpers and parts and pieces. When I was there, the Briggs and Stratton pallets and pallets of Briggs and Stratton engine covers for just lawnmowers were just stacked up. And I said, why? What's going on with that? Oh, they were the wrong, it's just the wrong shade of color. So then we took them all and we grind them up and we make pellets out of them. And they got to meet the certain strength requirements and other properties before we will actually melt these down to make the products. Curtis, anything else you would like to add to that?
No, just that it's pretty amazing the recycling amount of recycling we can do on probably propylene and the stuff that we use to make all of this product. I mean, chambers, they have tires in them. They've got carpet fibers. I mean, whatever meets our specification, which is quite amazing on our recycling side. So,
yeah, we have other manufacturing industries coming just to tour our site, not for wastewater or anything else, but just to look at our recycling operation and how massive it is. I mean, think of 200 tons a day, 200 tons a day getting processed. It's quite the process. And the whole checks and balances and testing that's required for that is quite extraordinary. It's a real story to tell.
All right, let's see. Next question. Couldn't tree roots disconnect sections of easy flow from each other? Seems risky to have trees next to seepage field.
Yeah, so once that system is in and it's backfilled, it's not moving. Yeah, tree roots will grow in between them or even through the aggregate, but we haven't seen it ever be a problem. If a system is failing and we dig it up, usually it's homeowner abuse, again, the litany of issues, right? It's the leaky fixtures they didn't realize. It's, oh, we have a garbage disposal. Oh, we don't use it. Any of you ever heard that one before? But there's this much solids and sludge in the drain field. So, but the roots thing, I just think it's one of those myths out there, right? Are roots a problem in sanitary sewers? Absolutely. Are they a problem with drain fields? Haven't seen it. And again, I think if you were to dig up 100 drain fields, you'd probably find over half of them are not full of roots, but have root intrusion. Because again, there's water, there's phosphorus, there's nitrogen. The roots are going to find it. And again, we like to keep our system shallow, especially in Illinois because of the water table. Like to keep them shallow. Those roots are going to find it, but we just really haven't found it to be an issue. Is there every once in a while, once a year, I'll get a picture of just these massive roots that actually have grown to actually fill a 4-inch pipe, and they sawzall it. I tell the contractor, you got to send me pictures. I don't believe him. Sure enough, he cuts it, and there's a single root, filling up the whole
yeah.
diameter of the 4-inch PVC. So yeah, there's those anomalies out there, but we don't really see roots being a problem. Curtis, what else would you add to that?
Yeah, that's I was going to just point out we've had a couple in Illinois where typically before I enter that one back to the disconnecting of sections, quite frankly that wouldn't matter anyway because the trench is excavated and you got to look at easy flow as basically a pile of stone at that point in the trench itself. So I've been a part of this product now for 24 years and I've never seen one of those happen. Secondly, on the root intrusion, almost always it is bound up at the inlet of the line and going into the 4-inch pipe and then back to either the D box or the tank. So, and Dennis is right. We've seen that several times. And it's typically the only time I will almost always see that is if it's down a row of willow trees, a row of willows. The weeping willows are they drink a lot of effluent, but they can be trouble in the beginning of the systems. But typically, they won't ever shut off the system
Yeah.
completely.
Yeah, they can be
So,
pretty aggressive.
mhm.
Okay, awesome. We have a few more questions. All right. CDT system requires what coefficient of sand granule?
Well, there's a whole specification there. If you look at the sieve analysis, there's a gradation of sand there. And the most important one, I like to say, is that number 200 sieve, if you're familiar with that. So that's the real fine material, the silt and clay that actually gets through. We like that to be, less than 5%. And the reason why is if it gets too silty, too clay, or too much clay, what do those particles look like? I don't know if they can see my picture or anything, but think of those as plate structures, right? They're plate structures. So in nature, those silts and clays are randomly placed within the soil structure. But if you take that soil, like you take a clay and I dig it up and I put it in the truck and I in the dump truck, drive it 20, miles down the street, dump it, scoop it up, and all the time I keep moving and adding mechanical energy to a silt or clay soil, those clay particles start lining up like plates and we form what's called a brick, right? So we reduce our permeability. So whenever we import soil to a site, like every state has, if it's imported soil, you shall have a clean, coarse sand just for that reason, because you can manipulate sand, carry it, dump it, and you're really not changing the permeability characteristics. But if I were to do that with a wet clay, I make a brick. So does that kind of answer the question? Does that make sense?
Just think more coarser sand.
Okay. Let's see. What are the environmental impacts of the system? Styrofoam breaks down over time, introducing more microplastic.
So you saw the inertness letter, and does it break down over time? I'd have to say yes. The product's been installed for almost 40 years now. We haven't seen any sites where there is sampling underneath the system where there's any microplastics issues, and it's stable in a sense that we have that sand, that soil, that native soil underneath, which is finer. Those microplastics, those particles are going to get bound up in the soil, just like wastewater or the particles in wastewater would as well. So we're not seeing a plume of microplastics moving. They'll get bound up, they'll get held up in that soil.
Agreed.
To install an ATL system, do the contractors need to be certified online? I hope I'm reading that right. Need to certify.
Yeah. Unfortunately, when we rolled out ATL, that was not part of the process. Um, however, I pretty much have most of those guys go through the AES training as well, because they're such similar products, with the only difference being the couplers, how you kind of snap the products together, but they all perform the same way. So if someone's doing ATL, I do all I can to try to force them to go through the AES training, at least to have certification on CTD systems. That's something we should probably look at down the road. So
Okay. Has there been system components that include the polyfoam been exhumed after years of use? What do those look like over time? Are they still viable for many years? It seems like they would degrade and become non-viable.
So I'll go first, Curtis, and you can jump
okay,
in. So
sure.
we do provide support, and support means, okay, hey, my system's 12 years old. It's a little premature to be failing, but I got surfacing effluent in the backyard. So we go out with the contractor, the licensed contractor, dig up the system, and sure enough, they punch through the easy flow and the beads, maybe fall out. They look like the day they were installed. We don't really see any degradation over time, at least in that time period. So they seem to be very stable, hold their shape, hold their form, and keep in mind, I tell everyone, the product, whether it be CTD or Easy Flow or Stone and Pipe or Chambers, it's not a magic box, right? If the homeowner wants to abuse it, there's going to be issues. By that, I mean the same things we had talked about, right? Whether it be leaky fixtures and they don't realize it, or never pumping their septic tank. I mean, there's a whole laundry list of why systems fail. What about, okay, I put in the pool in the backyard, now all the runoff hits it, or I put in a garage and drove over my system and compacted the heck out of it. And now all the runoff runs over the, I mean, it goes on and on. There's been a litany of issues that we've seen out in the field. But when we dig up the chambers, of course, they look fine. And the Easy Flow, the same thing. We haven't really seen any issues with it degrading over time. Curtis, what would you add to that?
Yeah, honestly, I've dug up several of these, and after they've been in the ground, and we've done some tests here in Missouri, and same thing. We dug the systems out. A lot of our soils over here are pretty heavy clays, so it was a great place to actually do the study work on it. And it was basically to get a further reduction. So we were pulling the beads out to look at the beads. We've got pictures of that type of stuff in the study, and Dr. Severs did that one for us here in Missouri. So I've seen a couple of them crushed, but it took a D9 with very minimal cover on top of it that should never been on top of the systems to begin with. It would have compacted anything. Secondly, the question, I don't know if it came up or chemicals, I think earlier on this, we used to carry around mason jars full of beads in a jar that had all the different chemicals from houses and cleaning chemicals. It literally would eat the lids of the jars off before it would touch the actual pellet themselves. So it is extremely strong product. And but yeah, if you crush this, you've worked at it to do it. So
All right, and then our last question. I understand that AES pipe configuration is preference, but do you recommend one over another? Serial, manifold, header, D-box, etc.
So I'll jump in first, Curtis.
yeah,
I can tell you some designers nationwide like have a strong preference, like, hey, Dennis, I like to have equal distribution. I want a manifold, and that's the only way systems work. I'm like, okay, knock your socks off, have a manifold, use uh, other things like if certainly if it's on a slope, I would strongly recommend serial distribution. Um, because anytime we have a distribution box in front of our system or any system, right? A distribution box does not give equal distribution. It never has, it never will. When the contractor installs it, yes, it's level, but 1 or 2 or 3 years later with frost and settlement, all the flow is going to go out one hole because there's just a little bit of settlement. And with gravity flow, gravity systems, it's just a trickle. So all the flow goes out the lowest hole in the distribution box. So by default, Mother Nature is serial distribution. People don't want to know that or want to hear that, but that's fine. It works great. Mother Nature is very forgiving, and those microbes in the soils are just waiting to be fed, and we don't see an issue. So I would say my preference would be if you're on a slope, I would strongly recommend serial distribution. And if you're on a level site, then we can go level header or serial, and we'll be fine. Curtis, what would you add to that?
yeah, pumps typically the only time they're pumping to any of these systems, quite frankly, unless it's a large commercial application, is to get it up higher in the soil. So I don't have one preference over another as far as that goes. But Dennis hit it on the head. If you're on a slope, there's no reason to dig a level bed. The system should be on a slope. Pumping, you always got to have a D box anyway because we want to slow that turbidity down before it kind of gets out into the field. I think another question was ATL versus AES. I don't really have a preference there, with the exception of when we purchased Presby in 2018. They already had a 20 plus year track record with this product. So we've kind of chosen in our markets over here to do more advanced envirosectip over the ATL, simply for that factor alone. is that that product's been tested in the ground for a lot longer, and that would be the only reason. It's crazy for those of you that have seen a lot of these CTD systems go in. It's one of the biggest issues was the vent. People just did not want the candy cane vent in their yard. And when we were able to establish that the treatment process was really no different, because ATL never had to have it when we ran that through NSF 40 as well. Once that application went, I'm going to say 90% of what we see now is advanced enviroseptic over ATL.
Awesome. Well, I just want to say again, thank you, Dennis. Thank you, Curtis, for your presentation for today. That is going to segue us completely into our next presentation. For our second presenter, we were going to have Brett Weber. Unfortunately, Brett Weber is not able to present in person, but I do have a pre-recording of his presentation that I'm going to go ahead and share. As far as questions, I think the easiest thing might do, if anyone that we might do, if anyone has questions in the middle of his presentation, if you just put them in the chat, I'll kind of combine them all together and then I'll email IEHA to let them know these are the questions and try and connect with him to see if we can get those answered. So without further ado, I'm going to go ahead and share my screen and do our next presentation.
Thank you, everybody, for having us.
Thank you, Curtis.
You got it. Take care.
You too.
Good afternoon, everyone. My name is Brett Weber. I'm the Vice President of Treatment System Sales at Norweco. And I want to thank all of you for attending today. I also want to thank the Illinois Environmental Health Association, along with Heather Anderson in particular, for allowing me to do this remotely. Currently, while you're hearing this, I'm actually on the way to Chicago with my oldest son, who was accepted into the Chicago-Kent College of Law, and that came up very recently. So now I'm just very thankful that I'm allowed to do this virtually, but of course, I want to let everyone know I will be available to answer any questions. So you can see our phone number here is 419-668-4471, and there's my email address as well. Please feel free to call or email me following this presentation, and of course, anytime if you have questions, whether out in the field or anything about our designs or availability, please give us a call. Anytime. We will be available to answer your questions, and we are always happy to help. So I want to start off with an introduction about Norweco very quickly, and then we'll get into the Singulair technology. And we're going to talk about both Singulair Concrete and Singulair Green. We're also going to go over the treatment process, the treatment efficacy, along with some information about installation, service, troubleshooting, and proper pumping. So I hope to get to all of that during this hour, and again, invite any of your questions or feedback following the presentation. Norweco was originally founded in 1906 and actually got into wastewater in February of 1972. So they saw a demonstrated need to help with residential on-site wastewater treatment and got into that in 1972 with the Singulair system. So we do have now almost or just over 54 years of experience, and obviously we'll continue this for decades and centuries to come. Our motto, progress through service since 1906, really nicely sums up our commitment to quality products, as well as our employees and our community, and also, of course, the on-site industry as a whole. Now, as we get into the way that the Singulair technology works, I do want to briefly go over and remind everyone of the wastewater treatment fundamentals listed here. Primary treatment, secondary treatment, tertiary treatment, along with disinfection. Those of you who are not aware, the Singulair system is a 4-stage system. And as you can see here, you can see the 3 chambers, pre-treatment. I do want to point out that in the base model Singulair Concrete, along with Singulair Green, that is going to be a 450-gallon chamber to the design level. Next, of course, you have aeration, and this is really where the heartbeat of our system, the Singulair 206C or the new low-profile 225L aerator, is going to be operational half the time, right? So a total of 12 hours per day. Typically in Illinois, that's going to be 30 minutes on, followed by a 30-minute anoxic cycle. But we also do offer a total nitrogen reducing system that will run the aerator 1 hour on, followed by a 1 hour anoxic cycle. That total capacity for the chamber there is going to be 600 gallons to the design level, and it is, of course, the largest. It's going to be the chamber that holds wastewater for 24 hours retention of the average daily flow. And then last but not least, you have the clarifier. So this is the smallest chamber in the Singulaire technology. This is going to have a 6-hour retention time of the daily flow. But very importantly, this is going to be where final filtration takes place through the biokinetic system. We're going to talk more about that, but here is our demonstration cutout of the BK system that also functions as a flow equalization device. So I would pause here just to point out that there is 1,300 gallons total capacity, again, in the base model concrete or the Singulaire Green, both of which are NSF certified to treat up to 600 gallon per day. But there's also over 250 gallon of freeboard area for when surges occur. Now, we just got done with the Super Bowl, obviously prior to that, Christmas, New Year, other holidays, and that's where this is going to really, really help the homeowner because, again, life doesn't just happen routinely every day. There are surges into the system, and our biokinetic system really is unique in the industry in that it's going to hold back those surges that occur to ensure that only fully treated effluent is going to go out into the environment or to the disposal area, right? As opposed to partially treated or untreated effluent. The final thing I want to say, I did not mention, the pre-treatment chamber has 18-hour retention of the daily flow. So you can see in 48 total hours, the Singulaire process will take that raw domestic strength wastewater and treat it to extremely high levels. And don't take my word for it, although I hope you will. But if you look at our field data, if you look at our third-party certification tests, which I can provide to any of you upon request, you will see that the Singulaire technology, you can count on it. And most importantly, the citizens of Illinois can count on it to treat all of their wastewater to a very, very high level. So getting back to those fundamentals of wastewater treatment, first, of course, all wastewater is going to enter the pre-treatment chamber of the Singulaire system. Now, this is where non-biological material is going to settle out, and biological material is going to continue on into the aeration chamber for further treatment. And again, I mentioned before, this is where there's 18-hour retention of the daily flow. Think of this as, for lack of a better term, an integrated septic tank to the Singulaire system. Next, of course, this is the secondary aggressive treatment, the aeration chamber. That's where this occurs, and this is where aerobic bacteria is going to go to work. Aerobic bacteria in the chamber is going to mix. It's going to be stimulated by virtue of that of our aerator running again during that 30-minute cycle, where in addition to delivering 3 cubic feet of air, it's going to be spinning counterclockwise 1,725 revolutions per minute, and the combination of that agitation along with delivering that air is going to stimulate the growth of that good aerobic bacteria, ensuring complete oxidation of all organic material in the wastewater. Then, of course, we have the clarification chamber, right? This is where that tertiary treatment is going to take place by virtue of the interplay between the biostatic sludge return that you see on the inlet side there, and you'll see that, again, both in concrete and green, along with the biokinetic system that is always going to be at the outlet of a Singulaire system. Now, here in Illinois, you will see larger capacity concrete systems. Those will have 2 or 3 biokinetic systems and 1 or 2 biostatic sludge returns, depending on the size of the system and the configuration. But again, this is where during the anoxic cycle, settled sludge is going to be directed to the bottom of the sloped clarifier. And when the aerator is activated, it's then going to pull that settled sludge back into aeration for further treatment. Very importantly, that will eliminate or at least significantly reduce the retention of solids, which is great for treatment, but also good news for the ultimate end user, usually the homeowner, because it's going to ensure that they do not have to have their system pumped nearly as much as a standard septic tank. I would stop here to point out in Illinois, we are very blessed, just like we are here in Ohio, to have some wonderful long-term distributor partners. And the ones that I would say single out in particular, of course, Conan Concrete in Germantown, Rex Vault, which is in Newton, Illinois, along with Unique Concrete in Jerseyville, right along the Mississippi River. So they, along with several new or strictly singular green partners, form the backbone of our network in Illinois, and they're all wonderful people. And again, if you ever have questions about the nearest distributor partner to you, please give me or our customer service team a call. I mentioned a few slides ago the aerator being the heartbeat of the Singulair technology, and I do want to pause to point out, I think you've all heard of or seen probably our long-term aerator, the Model 206C. We now offer, here's the 206C, we now offer a low-profile aerator that we've designated the Model 225L. This can be inserted into a low-profile Singulair green, and all of our Illinois partners, at least as far as I know, have purchased a very simple modification kit to allow them to install the 225L in the aeration chamber of the Singulair concrete system. I do want to point out that this has been approved by NSF. We do actually have an equivalency letter, and that has allowed many state departments of environmental protection or health departments, as the case may be, to quickly approve that. And again, there's no exception in Illinois. It is approved for use when and as necessary. I would just point out that these aerators are indistinguishable in terms of the motor bell and the spinning at 725 RPM and delivering that 3 cubic feet of air, and also where they're going to fall in aeration. The only difference is the bracket pattern, and you can see here obviously that change in the bracket pattern and a slight reduction of the length of the aspirator shaft for our 225L reduces the overall profile of a tank by 6 inches, which, as you all know, in shallow lots or lots that have other challenges, that can make a huge difference in terms of inconvenience to the homeowner, most importantly, but also the work that needs to be performed by one of the professional installers that work with our partners. The biostatic sludge return, I've mentioned this before, it's a very simple plastic duct, or ducts in the case of the larger capacity Singulair systems, but they do perform a very vital purpose. They're going to direct settled solids that come into clarification to the bottom of that sloped hopper. And they're going to be returned and resuspended in aeration. And by virtue of this, of course, the wastewater will be fully treated. And again, that's very important for the homeowner, whether they're discharging off-lot through, for example, an NPDES permit, or on-lot to their disposal area. Because again, if you have partially treated or untreated effluent going into the disposal area that's on-lot, you will quickly get that filled up, and it will require remediation, including but not limited to potentially removal and replacement. The biokinetic system, too, again, is very simple, and we keep that theory of simplicity because, again, our technology works very well, and we want it to be easy to understand, easy to maintain, and again, we've accomplished that with Singulair. The bottom line is, as the treated wastewater is entering the clarifier, the biokinetic system works in concert with that biostatic sludge return. And as the water then leaves the system, you're going to be assured, passing through this NSF certified filter, that any remaining solids are going to be, most remaining solids are be removed from the effluent. And if disinfection is required, this is also an NSF standard 46 and 385 certified disinfection device. But what makes the BK system, in addition to those two great things, stand out is the fact it is a flow equalization device. And I will just say it works in concert with that freeboard back through the Singulair that I mentioned to assure the homeowner, to assure you as environmental professionals that only fully treated effluent is going to get out of the system. So that's a very important thing that I just wanted to focus on. We also do offer through our partners a lifetime warranty and exchange program. I'm not going to spend a lot of time going over that other than to tell you what that means is that a homeowner or system user will never pay full price for an aerator. After a 3-year warranty, which covers all the components, including the aerator, there is a lifetime exchange program on our 206C and 225L aerators. So our partners, again, the Conans, the Rexes, the Uniques, and other valued partners in Illinois will always be able to get a credit for the aerators that they return to us. And again, they are very good about making sure they're selling those to service providers and ultimately the homeowner at a very competitive price. We also, I think all of you know, do offer a suite of Service Pro control centers. Things that are as simple as being able to run just the aerator all the way up to our WASP control panel, which actually will run one 206C or 225L aerator along with one high-head effluent pump. I would pause here just to point out that we do offer private label effluent pumps. It's called the HB105 is the most popular. Certainly our partners do not have to buy our pumps. We are not a pump manufacturer, but we do mention to them that if they're going to purchase the WASP and they're going to use pumps that either they're a distributor of or they have access to locally, just to make sure that the pump curve and the amp draw and things like that are the same or similar to our HB105. And just like for them, for all of you, that information is available upon request. Okay. So now we are going to talk a little bit about the singular green. Now in Illinois, again, all of those partners I've mentioned, right? So Conan, Rex, Unique, several others, they're precasters that generally are going to use concrete. Now they do lean into using the high-density polyethylene singular green when and as warranted, and we do have several green-only dealers in Illinois as well that are very valuable and that often will install the singular green system, or they'll buy concrete from one of our local concrete distributors and then populate them with equipment packages that they purchase direct from us. But we make every singular green system, every singular green tank here in Norwalk, and we've invested now in 6 rotational molding machines. And as I understand it, there's plans to have up to 10 here in the not too distant future. So we do like to talk about singular green, but also making clear, particularly in states like Illinois, Ohio, really all the states, with one exception being Florida, where we're active, green is typically going to be an adjunct to singular concrete. But just like the base model singular concrete tank, the singular green system is a very small footprint to produce a very high level of effluent treatment. You can see here the dimensions. I would also point out that Norweco has recently invested in molds that actually allow for connection points on all of the tankage that is integrated to make the singular green system. What that means is that we can integrate downstream tankage, and we've already done that in the form of our hydrokinetic biofilm reactor. We also offer it with an integrated 520-gallon pump chamber. And the latter is actually a lot more popular just in Florida, for example, into drip, in Ohio for NPDES applications. So again, we're continuing to evolve with regard to our singular green technology and what we offer to our partners. I would also point out the only difference between singular green and singular concrete is the material it's made out of. And that's a huge difference because you have concrete, which typically is going to weigh in at between 10 and 12,000. If it's a 600 gallon per day system, 10 to 12,000 pounds. Whereas the singular green weighs 1,000 pounds, give or take, with the components installed. So again, this is great for lots that are very small. We see this all over the place in Florida. And or lots that cannot be accessed, or if the homeowner just does not want to have a heavy crane truck showing up on their lot, because you can deliver singular green literally with a mini excavator, so a lot less, potential damage to the lot and the landscaping when delivering singular green versus singular concrete. That stated, concrete is the absolute bread and butter, and I just want to emphasize that we in no way are suggesting that green is going to take over or cannibalize concrete. We do offer it really at our distributor's request as an adjunct, and it has built up its own little market in various areas. We do offer riser extensions. I would stop here to point out that no matter what, you want to limit the burial depth for singular green to 36 inches, so 3 feet. This is less about structural integrity and more about safety for the installers and obviously service providers, because if you get too deep, even with our extensions that are available, riser extensions, it's going to be really hard to remove and service the aerator and the BK system. So again, that's a pretty hard and fast rule, and if there are any questions about that, obviously please give us or your local distributor partner a call. Singular green actually consists of, as you can see here, it's actually 3 different independent chambers that are fastened together by what we call rivet rivets, and they're also then the internal components, so the inlet tee from pretreatment to aeration, along with the biostatic sludge return that's between aeration and the clarifier, are going to do double duty. There's nuts that are actually torqued down by our colleagues in production next door, and they torque those down to 100 foot-pounds, so they do double duty. You can see the 12 locking rivets. There also are 6 lifting lugs that are integrated into the standard singular green system. I would just pause here to say that when moving singular green, you always want to have at least 2 of those lifting lugs engaged on each side. There are various ways to do it. So again, we're not going to dictate that, but we are going to put in our instructions that you have to have at least 2 of those engaged at any given time. I also want to point out that there is a transfer port, just like with concrete. At the bottom, you can see that slope clarifier between aeration and the clarifier there. That is plastic welded, so the guys next door will make sure that is plastic welded, but that is not for structural integrity. It has nothing to do with structural integrity. It is simply for water tightness, because again, when that settled sludge is transferring from clarifier back to their aeration chamber, we don't want that leaking out. So we go that extra mile to make sure it is watertight. I won't spend too much time on this other to point out that the ownership team at Norweco insisted that the highest level of testing be done as they were developing, now about 20 years ago, singular green. Finite element analysis, FEA, you see on there, is extremely expensive, but it also makes sure that any weaknesses, any points that are real or perceived points of weakness can be designed out, and Norweco was happy to make that investment to ensure that singular green is literally every bit as up to the challenge of wastewater treatment as concrete. And again, I mentioned before, those threaded connections and the welded connections, that's a good representation of that for you to see a good cross section there, and you can see the aerators there. The only difference, if you have the 225L aerator, is that all 3 of these risers are going to be 6 inches lower, and that 225L will be seated in a slightly different aeration mounting casting that's inside of our singular green system. So now we're going to get into singular system performance, and as we do this, I'm going to promote this a few more times. We do offer an app, and we've recently updated that app. It's inventively the Norweco app. If you download that, and right now if you input the promo code GO225L, that would be in all caps, you'll have immediate access to it, and it contains all sorts of useful information about Norweco technologies. Certainly focuses on singular, but we offer some other technologies, including what we call the hydrokinetic system. That is a niche system that is very popular in really strict areas. So up north of the border in Quebec and Ontario, for instance, that's where that is sold, along with Long Island, Suffolk County. We are one of very few manufacturers who have made it through that Save Our Septic program, and the HK 2.0 is about to receive the general approval there, so we're very, very excited about that. Singular is and will continue to be, though, the go-to in Illinois and most of the United States. It is an excellent system in its own right. And if you want to get more information, or if you're ever looking for drawings or anything, and it's not during business hours, which for us is 8:30 a.m. to 5 p.m. Weekdays Eastern time, you'll have access to all of these things through our app. So again, take a look at it. We will not be soliciting you. We will not, use that to sell your information or anything like that. It is simply to impart information. So, as you can imagine, being in this industry, we have had to invest in third-party certifications, and we're happy to do that because, again, that takes any guesswork out of how well any technology works. And any of you can have access whether to our executive summaries or the entire NSF certification reports upon request for the Singular technology. And it is safe to say you will be very happy when you take a look at how well Singular performs in third-party testing. But I think all of you will agree with this statement. How it operates in the field really is what's most relevant. And over the years, again, for various state approvals, also for various projects, we have engaged third-party testing companies to test, field test Singular in the real world, and it is fantastic. And again, I can say that objectively because these are third-party test organizations and laboratories that are pulling samples from residences where obviously we have no ability to have any impact on them, and it's less of a controlled environment than even third-party testing. So if you ever want to take a look at that for your own intellectual curiosity, or it's something that could help you out in the field, just please let one of us know and we will get that to you. You guys know all of the wastewater constituents, so I'm just going to kind of just leave those up for a second, but I won't list them all because, again, you're all at least as familiar with those as I am. Also point out here, you see, this is the Model 960 Singular system, the concrete one, and it is the base model. If you take a look at this next slide, you'll see its performance in third-party testing, right? So it's getting at these third-party test sites domestic strength wastewater, right? That's anywhere from 100 to 350 roughly milligram per liter, both BOD and solids. And you can see during that test period how well Singular performed. Single-digit CBOD and 10 milligram per liter TSS, again in the standard 40 test. Now I just want to point out here, this is the Singular Model TNT, and I would also point out the green comes in both models as well. But you'll look at that and think, well, geez, that looks just like the slide from 2 slides ago, and that's exactly right, because the only difference between the Singular Model 960 and the Singular Model TNT, again, so the standard 40 system that you're all familiar with, and then the standard 40 and 245 system that I don't think is often used, if ever, in Illinois, but certainly is available. The only difference is a simple control panel insert, right? So one of our Service Pro control centers. Well, what does that mean for you? What does that mean for citizens of Illinois and all of our valued customers and system users? What that means is that the Singulars can be modified or converted from 40 to 245 and vice versa in literally less than 20 minutes by virtue of a panel swap. And that is something we're always, again, trying to keep it simple, but also keeping things useful. So if there ever was a retroactive code change, if that ever were to occur, people are assured that their system, their Singular system, can easily be made to fight total nitrogen, for example, or reduce total nitrogen, and be certified to that with a very quick in-field panel swap. And again, we're very proud of that, and it's something it's safe to say does help us stand out in the industry. I would point out here are the results from the standard 245 test, and you can see here that with regard to BOD and solids, just a slightly better performance. And again, the only difference would be the aerator running an hour on followed by an hour off cycle. But look at this total nitrogen reduction. 68% on average. And again, in field testing, it does even better than that in the mid-70s. The Singular technology accomplishes that without the tried and true recirculation from the clarifier back to the anoxic chamber. You all know that's typically how that's done. And as a matter of fact, that is how it works with our hydrokinetic system. That's a big part of our hydrokinetic system that I just mentioned. And that's wonderful. But again, you're adding an electromechanical component, and that is something for the homeowner that can be a nuisance. Even service providers can be a nuisance, and all of you too, when doing inspections or checking on alarm calls and things like that. That is another component that can go go bad. So we have accomplished an excellent and aggressive reduction of total nitrogen through our TNT without that, just by virtue of the aerator run cycle. I mentioned before the biokinetic system being certified to NSF standards 46 and 385. Here's a nice little cross section. So that just shows how the BK, in addition to being that filter and a flow equalization device, it can be utilized to disinfect and dechlorinate waste, the final effluent actually as it's leaving the system. We also offer one of the industry's only NSF 385 certified UV systems in the form of our AT 1500. And you can see here we've actually gone to great lengths to engineer this to be the best disinfection device on the market today. And you can see through our NSF testing there, that 385 testing, how aggressively it reduced fecal coliform during that test. Now, if there is any sampling required in your jurisdictions, obviously I think you all know how to do that, and I would not presume otherwise. But if you do have questions or you want a resource, please give us a call. We do have sampling documents that we have prepared for all of your use upon request. And I think those are on our app as well. If they're not, I'll make sure that they are. And again, always feel free to reach out to us for those resources as well. All right, so next we're going to get into singular tank installation. I'm going to run through this fairly quickly, but I do want to point out this is going to be the installation of one of our concrete singular systems. A lot of it is similar with regard to singular green, but again, you're going to see a big crane truck here delivering the singular concrete casting, and obviously with singular green, something that can actually fit in the back of a full-size pickup truck and can be easily moved by a mini excavator or other small implement. I do want to point out, we talk about singular technology and hydrokinetic technology being applicable to residential applications, and that is typically the case, but I just want to point out that where state and local code allows, there are a lot of uses for particularly larger capacity concrete singular systems to be utilized in what I'll call small commercial type settings. For example, we have a partner who utilizes them behind Dollar General stores in western Pennsylvania. We have a partner in Maryland who utilizes them after some grease traps and some other implements in advance for the wastewater coming from Dunkin' Donuts. The big phrase, of course, is what is the wastewater strength when it gets to the singular system? And as long as it's going to be domestic strength, even higher up on that scale, right? So in the mid 300s for both BOD and solids, and there's no chemicals or other high strength components, Singular is going to do a wonderful job and will be in many cases preferable to having a package plant. So again, I do want to point all of that out and also just reiterate the fact that that would be respecting state and local code. Obviously, if there is a prohibition, we would not recommend it for anything where it is not locally allowed to be used. So here you see them preparing the excavation. It's very important. There's plenty of overdig, right, to get that backfill material in there. What's also critical is to have a 4-inch thick leveling pad of gravel or crushed stone. That would typically be what would be utilized. I will say that in some areas where gravel is either impossible or impractical to get, people will use sand. Florida is a great example of that. That works well too, but again, our instructions and best practice, of course, is to utilize gravel, at least for both the base and a certain part of the backfill. 4-inch thick, and it should be leveled 1/4 inch lengthwise and widthwise. That's very important for the operation of the biokinetic and the aerator or aerators. Here you see what I was talking about previously, right? A giant crane truck is showing up carrying that approximately 12,000 pound casting in this case. This is a mid-seam tank. I think that is typical of what you'll see in Illinois. Again, I'm virtually certain from the partners I've mentioned, so the Conans, the Rexes, the Uniques, you're typically going to see that. They do a great job when they utilize a mid-seam tank of making sure those are sealed, and there's absolutely no worry there. They all do a wonderful job of that. This is technically a 3-piece tank because here you'll see the risers are not yet installed. I will say you're going to see concrete risers in this. Typically now people are casting in plastic. That really is the way of the future. And typically too, those are going to be affixed to the tank at the facility, so before delivery. This is a good point to point out that Singular, again, whether concrete or green, if concrete, even everything from the 600 gallon all the way up to the 1500 gallon, it's going to have 4 inches of fall through the system, right? So 4 inches from the inlet to the outlet. So it's a gravity flow system and has either 1 or 2 at most electromagnetic components in the system between inlet and outlet. Here you see them unloading the tank, obviously being very careful to make sure that people are out of the way, and they are able to carefully set that into the excavation there. Here you'll see that they will not disengage the lifting device, that lifting beam, until they've confirmed that it is level from a quarter inch lengthwise and widthwise. So you see that here in that next slide. If it is not, if it's way out of tolerance, it is very important to just remove that tank completely, get it out of the picture, so the guys can safely go in there and obviously make whatever adjustments they have to make. Here you see our tank access openings. Now again, more and more you're going to see the risers already in place, and typically again plastic risers. I would just point out, you see these access openings are slightly different across the board. And here in particular, that's going to be the clarifier, and that's going to be where that biokinetic system is going to be fit into the top of the clarifier, and that's something we'll get into here in the component installation portion. We'll just go through that. We just pass through this because, again, typically they're not going to be sealing the risers in the field, but if they do, obviously we have instructions to cover that, and these gentlemen are following that very well. One of the things I will just say that, again, our partners all across the country, but I know Illinois is your main concern. As I mentioned before, they do an excellent job of ensuring that these tanks are sealed. That is very important, of course, because you don't want to have infiltration of wastewater into the world around that tank. And again, we take that very seriously, as do all of our valued partners. Here's the cable. So we do recommend at a minimum 14-2 cable that's going to power either the 225L or 206C aerator. The sewer inlet trench will typically do double duty. By in addition to that inlet line, you can have that 14-2 cable running through there. They're placing conduit here. I'll just point out that our aerator mounting casting, whether it's for the 206C or now, again, if they've bought the modification kit to accommodate the 225L, there's a knockout there where they'll put that wire through to power the aerator, and then they'll just seal that up to ensure that the mounting casting, again, isn't an area where gases or air will escape. You can see here, too, they're adding water. This is the hold-down water. We do recommend 200 to 300 gallons, regardless of if it's concrete or plastic. That's going to ensure that as you're dumping carefully, that backfill material in the form of hopefully crushed stone or gravel doesn't move the tank. Now, it's a bit more of a concern with green, but it's also important to do that with concrete as well. Here you see they're going to put the lids in place. Now, this is prior, of course, to putting the components in the tank, but that's going to be for when they're dumping that material there. You want to avoid as much as possible having, stone, clay, construction spoils go into the Singular system. It is a robust technology. If a little bit of that gets in there, it's not the end of the world, but if more than a little bit gets in, it's not going to kill the system, but it could negatively impact the treatment process. It could also cause premature issues in terms of having to pump it earlier than what would be required if they just simply had these in place and were careful as they did the backfill. You do want to backfill starting typically at the outlet side. You want to be real careful whether concrete or green to get that material under the slope clarifier, but it's particularly important to do that with Singular green. And basically just go around in 1 to 2 foot increments until you get, in the case of concrete, really just above, if there's a mid-seam, or in the case of a monolithic tank, just below that lid. The rest you can use native soil, obviously graded away from the system for obvious reasons. With regard to green, it is important to get that stone or sand up at least even with the inlet and outlet lines, and then you can use native soil the rest of the way, and again, make sure it's graded away from the system. If not, you'll have water pooling and potentially infiltrating into the system during snow melts or heavy rains and things like that. Now's a good time for me to pause. We do offer tool caddies through our partners, both a tool caddy for concrete, tool caddy light for green. I'm not suggesting that installers and service providers need to buy the entire toolkit, because we do, as an accommodation, put a lot of standard tools in it that are easily accessible or easily purchasable locally. But there are several custom tools that are very important to both items. One is our universal tool. Another one would be the hopper scraping tool. Another one would be an airflow meter. And the final one, I think, is imperative that we'll talk about all of these now or down the line during this presentation. These are things that are going to be very important to have for people if they're going to be looking at whether installing or servicing a singular technology. And again, all they have to do is contact our local partner, and they will give them information, including pricing on those, whether the whole kit or sold separate. We just point out the control center should be mounted either on a post by the system or maybe on the side of a nearby garage or shed. I think that's made to just point out it's a good practice not to have those inside the garage or inside a house. I know that I've personally been on some calls with distributor partners in Western Pennsylvania, for example, where they've asked us to go out there, or asked our partner, and I've been with them to go out and take a look at a system. You show up and they're either not home, or there's just maybe a kid at home, but the control panel is inside the house. I mean, in either case, we're not going to go inside the house, unless an adult is there, and so often that's not the case. So again, we just want that to be accessible at all times. I will just say we do have wiring instructions and wiring diagrams. In some areas, an electrician is required, and obviously we respect those local rules, but our technology, the Singular Aerator, the Singular Service Pro control centers, are very easy to install, to wire, and to troubleshoot. Here you see them wiring the aerator after it's been placed inside the system. Essentially, he's going to line up color-coded connections, and they really are very straightforward to make sure. People are very busy. They got to get on to the next project. We want to make it as simple and safe as we possibly can for those professionals who are doing the startup work and or going to be doing the service work down the line. Now, our pigtails are waterproof, and they really are of the highest quality, but one of the things that I found in my travels is that a little bit of dielectric grease goes a long way to avoiding premature oxidation of these. This is particularly noticeable, for example, in brackish areas like the eastern shore of Maryland or Florida, the coastline along the Carolinas and Georgia. But anywhere it will be helpful. Just a little dab of dielectric grease on that, the male part, and just plug that in and just kind of make sure it gets all around. Don't go overboard with it. Again, just something we've picked up that has been very beneficial to our partners, and so I want to pass that tidbit on to all of you. Our aerator is going to ship with the aspirator shaft not installed. Really, that's just for efficiencies in terms of shipping, so we do have to get that on. It's very simple. You put the aerator upside down and just line it up. It is tuned up at our shop, so there's a yellow marker on the aspirator shaft along with that foam restrictor, and so you can line that up immediately, and you do not have to over tighten that. Just hand tighten it down. That'll make the service provider very happy when he or she comes out in 6 months. Here you see him, I just mentioned that, securing that connection, and he's going to go to great lengths to not over tighten that. And again, if it happens, you can still remove it. It's just going to be a little harder to do, but more importantly, it could cause the aspirator shaft or even that intermediate shaft to dish a little bit, which eventually is going to require replacement, earlier than if they weren't doing that, and we're just like I said, hand tightening it. Placing the aerator is very simple, and I want to pause here to point out whether you're using our standard 206C or the 225L, you're talking about an implement that weighs just over 30 pounds, and it only draws 4 amps. So I know that there are a lot of rumors out there about our aerator weighing a lot and or drawing a lot of amps, and I will just point out neither is the case. We have done some studies that show that our aerator runs to the tune of between $12 to $17 a month. You're talking on average about $144 a year to run a Norweco aerator. And again, it is lightweight, and as long as you're careful with placing it and removing it from a singular system, it's going to run for really for years to come. It is important when placing it, whether in concrete or green, not to bump that aspirator shaft on the side of the riser. Again, a little bump here or there is not going to be the end of the world, but if you bump it too hard, it'll still work, but it's going to potentially get out of alignment faster, which will cause a premature aerator failure. Again, not the end of the world, because we do offer such an aggressive, not only warranty, but lifetime exchange policy. But again, we want the homeowner to get the absolute best value. And, we obviously want to honor that investment they've made, as I know you all do, and certainly our partners do. That electrical connection is very self-explanatory. Here you see the technician obviously plugging that in, and he's going to use clamps around the edge here to put that cord in, and you can see how that's going to work. Just imagine that power cord coming in here. That makes it easily accessible, and also so it doesn't droop, down past the aerator, which could cause problems. One of the other tools that we offer in our tool caddy, but I think which it's safe to say you can get pretty much anywhere, is an amp meter. You want to check that to make sure it's drawing that 4 amps. If you get a reading between 3.5 and 4.5, you're doing great. We also offer the proprietary airflow meter. That really is something that's hard to replace and hard to get anywhere else. And essentially what happens is you want to remove the handle here and just take that, put it there. It's going to form a vacuum. You're going to be drawing anywhere, that's going to read anywhere between 2.5 and 3.5 cubic feet per minute. And again, as long as that airflow meter is in that range, you are absolutely good to go. Here you see the completed installation of the, in this case, 206C aerator. The installation of the biokinetic system is also very simple, and it's very user-friendly as well. First thing you want to do, this receiving flange and the outlet coupling, you want to make sure you lubricate that. We do make available to our partners what we call biokinetic lube. That it's not necessary to have that. Just some sort of silicone-based lubrication would be definitely recommended to just ensure that biokinetic system is going to seat with that outlet coupling simply, or easily I should say, and also be able to be removed 6 months down the line when the service technician arrives to do service on the system. So you see that both there with the outlet coupling and then with the receiving flange that I just mentioned. First thing you want to do, this is actually in 2 parts. There's an outer assembly, so that outer assembly is going to be installed first, or the outer bucket we call it. So that'll go in. It's very straightforward. There are now drain and fill valves, and have been now for several decades, at the bottom of the BK bucket. There are also conversion kits. If you ever run into one that doesn't have that, please give one of our local partners, or failing that, us a call, and we can get you the conversion kit that's going to allow that bucket to fill as fast as you can put it down there, as opposed to having to struggle to get it down into the system. You see the technician here is being very careful as he installs it. It is important. You got media here, attached growth media, design flow and peak flow. And if you catch, particularly on a concrete, a burr as you're putting that in there, it could cause that media to rip. Now, again, the media is very stout. If it does rip, though, if there's an issue with it, we do offer to our partners a media replacement kit that is very easy to install to replace that media, which again is critical to the treatment process. You need to have this attached growth media to ensure the highest level of treatment. He's therefore going to check the alignment. Next, he's going to insert the inner assembly. Now, the inner assembly is where a lot of that filtration occurs, right? There are 7 settling zones within this biokinetic system. 7 filtration zones within this biokinetic system. And a big one is going to be through the 42 weir plates as it goes up what's called the snow fencing effect. So it is important to get that inner bucket in there and lined up properly. You can see there is that little yellow thing at the top there. That is actually a level indicator. And here you can see these screws that are inside of the through bolts can be utilized to tighten down and change the elevation of the BK. You want to work very hard to try to get that bubble there right between those 2 black lines. It's important on any singular system. It is critical to do that with a system that is going to utilize the feed tubes to deliver our blue crystal disinfection chlorination tablets and dechlorination downstream. Here's a good example of why that universal tool is important. He's using that to turn these 4 locking lugs into the grooves that are molded in the case of both concrete and green, to allow that BK system to be fully installed. You can see here the flow deck. Again, you just want to make sure that's level. The moisture vapor shield at the top, every BK system has this, and it's very important. You do not need to tighten it down. There's nothing to fasten it. There's 4 holes in that. Just make sure they each are seated into where the locking lugs are, and just push that down. It is critical. It's very simple to do, but it's also critical for the strength of the biokinetic system as it sits there in the clarifier. The structural integrity will be greatly aided by making sure you take the time to put that moisture vapor shield over it. Here you see them inserting the chlorination and the dechlorination tablets. Obviously, chlorination would go upstream, dechlor downstream. And while the tablet feeders that we sell can hold up to 24 tablets in most cases, you want to limit that to at most 8 of those tablets. And again, in the cases of chlorination, because of the dissolve rate, the homeowner is going to have to know, unless they want a service provider to come out, every 8 weeks to install new tablets, they're going to need to be given a quick tutorial as to how to refill the feed tube. So it's very simple and straightforward. But it's also why I think many jurisdictions are going to UV, because you don't have to do that and don't have to count on the homeowner. And again, we're very proud to offer both types. And what looks very simple is actually very ingenious. This safety net will actually hold up to 500 pounds. So it's rated for up to 500 pounds, and it's easily removable by a service provider who has the proper tools so that he or she can get into the system quickly. The last thing we want to have is a secondary safety device that's going to frustrate the efforts of those professionals who are out doing the startup and or service of a system. We actually just presented on this at the WET show roughly 2 weeks ago, and there are several secondary safety devices, and I would just end that by saying that Norweco joins, I think, a lot of folks in the industry in making, obviously quality and backing of our products is very important, but safety, it's not just cliche. It really is number one for us here at Norweco, and that would be for everyone. From our employees all the way down, of course, to the people who are in the field, the children, animals, and things like that that are going to be near the system. We want to make sure there are no accidents, obviously, with any technology, and what we can control is ours, and we'll work very hard to offer this secondary safety device, like I said, at cost to our partners, who in turn will offer it at a very, very low cost to the homeowner and other end users. Very important both with green and concrete. Now with green, we have changed from we used to have 4 screws and grommets for our lids. About 4.5 years ago, we changed to threaded. When we did that, we included a vent cap over the lid that goes over aeration. The other 2 are sealed, so it's very easy to see which one goes over aeration. And the same with concrete. Whether the partner is still using concrete risers and lids, it'll be obvious which one goes over aeration. Certainly if they're using plastic tough tight polylock, which again is becoming more and more the rule rather than the exception, it's very obvious as well. But it is imperative, and I cannot tell you how many times I've seen this get mixed up. I know people are busy. It's imperative that the vented access cover be placed over the aerator. And again, I won't get into that beyond the obvious, that it's very important. And I always tell our service folks that come here for training at the request of our partners for service, to take one last look as you're walking away from a system. Make sure that vented access cover is over aeration and the sealed are over pre-treatment and the clarifier, respectively. All right, so a few more things to go over. I want to quickly go over singular service. This is another slide for me just to, actually, the invite code is right there. Please consider downloading the Norweco app. I think you will all get a lot of information and get a lot of use out of it. If you don't, or you find it to be annoying for whatever reason, you can always delete it. But again, for all of you, and frankly anyone who's involved in permitting or inspecting that you want to pass this invite code on, again, go 225L is the invite code for the remainder of March. Right now it's March 2nd. If you don't get to it till April or beyond, just give us a call. We'll give you the updated invite code. We do change those typically monthly. This is going to be the service of a singular green system, but kind of unlike installation, where things are a little bit different between the two, including, again, the delivery mechanism used, service of singular and singular green really is indistinguishable in terms of the steps you have to take and what you have to do. The reason why we used this in this particular presentation is because, quite frankly, we have more contemporary pictures of servicing a singular green system than we do singular concrete. First thing you want to do when you arrive on site, you want to just really just depower the system. You do want to make sure, for reasons I'll talk about later, hopefully the aerator is running when you show up. There is a 50-50 chance of that. If not, activate it for just a few minutes and then proceed to power it off. And again, it'll be very self-explanatory on our control panels how you deactivate the aerator. Once you do that, the first step would be to remove the aeration access cover. Now, you'll see Wendy here is using, or is that a system with our old access covers? We now use threaded lids, but again, the principle is the same. You want to carefully remove that access cover. You then, of course, want to unplug the aerator that's already been depowered at the control center, and you then want to carefully remove that aerator. And again, you can see Wendy's being careful not to bump the side of the riser, but it's very easy for her to do that because this aerator is, again, just over 30 pounds, and she's just going to take the time not to bump that aspirator shaft on the side. This is where that advice about not over tightening those two set screws comes in, because you can see she's easily removing those two set screws so she can remove that aerator shaft from the intermediate shaft. First thing she's going to do is clean the motor shaft through the aerator. Now, with this, you want to utilize, and again, that's why I left this loose. You can use our, we do actually have a cleaning kit to utilize. It's a 45 caliber bore brush, actually, but all thread anything just to push through any buildup. Typically going to be soap buildup and things like that. But again, this is where the air is going to go. So it is very important just to take a few minutes to do that. Make sure you're getting that opening clear of any debris that's built up over 6 months. And again, one reminder I would have, do not ever put water under pressure through the aerator motor shaft, because you'll potentially knock bearings out of alignment and cause premature failure. Now you'll see, though, with the aspirator shaft that's been removed, certainly you want to run that bore brush through there. You also want to run it through these 4 aspirator tips. Again, just get rid of any buildup on there. There's always typically going to be buildup at the end after a 6 to 12 month period. It's just important, utilize a utility knife, some other kind of implement to take that off. I would strongly recommend having the ability to throw that in a waste can. Don't toss it in pre-treatment, and certainly don't just chuck it onto the homeowner's lawn, but just find a way to dispose of that. And again, taking that off is important, because while it's very robust, if it builds up to be like a bowling ball size, obviously you got 2 problems. It's potentially going to throw the aerator out of alignment as it wobbles with that, but also it's going to distinctly reduce the amount of air, and you're looking for that 3 cubic feet. Very importantly, you can utilize, as you see here, water under pressure through the aspirator shaft and through those tips as well. Now, I mentioned another custom tool, the outlet coupling sealing tool. This is going to be important to seat in the outlet coupling of the Singulair system prior to removing the biokinetic system for further service. Obviously, if you take the BK out without that, there's going to be a rush through, into the pump chamber or gravity, depending on how the system is set up. But either way, that's not a good thing. So this very simple blocking tool should be utilized, again, prior to removing the BK system. Here you see here during the reverse of what our colleague did previously, just carefully removing that moisture vapor shield. Just set that aside. That requires no service. Just set it aside, and you'll just reinstall that. She's going to remove that inner assembly. Now, this is going to have to be serviced every 6 months or every service interval, but it's very simple. We used to recommend taking apart the inner assembly and washing all those 42 wear plates. I'm here to tell you that best practice actually is not to do that. Whether you're doing it on lot, and if you are, be careful, or if you have a critical mass and you're able to take back the biokinetic system and replace it with a clean one back to your facility for further service, you want to take care to get water under pressure, as she's doing here, through that receiving flange, and just literally move that inner assembly back and forth and side to side for roughly 20 to 30 seconds. Any excess buildup throughout the BK system will slough off. It is open bottom. That BK inner assembly is open bottom. It will slough off, in this case, into pre-treatment using our safety service guard, or at the shop. All 3 of our distributors in Illinois, the big ones, again, Conan, Rex, and Unique, have ways to do this on site, so they'll just replace it with a clean biokinetic system. But it doesn't have to be perfect. In fact, you might want to leave some of that growth there for a more efficient restart after service. And again, that should be done every 6 months. The outer bucket only actually needs to be serviced in a properly operating system every year. So that's kind of the same thing. You just remove that, put it over pre-treatment, or again, take it back. If you're going to do it on lot, obviously don't use a jet that's that strong, because what's going to happen is a lot of that stuff's going to just blow off onto the homeowner's yard, and we certainly don't want that out of respect, if nothing else. But you just want to make sure you get a lot of that biofilm, any excess biofilm off there, but you can leave a lot. You can leave some of it there, right? Because again, that is an important part of the treatment process. So having it as white as that right there is not the best practice. That's probably a 15 to 20 second operation. You next then reinstall the aerator, which again, we've done that previously in those slides about installation. Reinstall the biokinetic system, making sure that inner assembly is level in there, and turning those posts is necessary to make sure that happens. You're talking about 3-4 minutes total to get that all done, because again, we've got that fill valve now. As you put that in, it's going to fill. Also, when she pulled out that outer bucket, it will drain as fast as you can fill it out. You just need to utilize our universal tool to activate both of those implements. Then you see her reinstalling that moisture vapor shield, and finally removing that outlet coupling sealing tool. Now, this is a very important step, and I would be remiss if I didn't remind folks to do that, because again, it's the little things that could cause problems. Obviously, if that sealing tool is there, once you recommission the system, then it's not going to be long before the homeowner is going to get an alarm, because the aerator is going to stop working when that flow hits that foam restrictor here at the bottom of our aerators. Then you're going to go back to the control panel, of course, and you're going to literally just hold down the power button for 5 seconds. It will restart the aerator, and make sure you close that back up. Reinstall the lids, obviously again making sure the vented cover is over aeration, the sealed ones are over pre-treatment and the clarifier respectively. Reminder about the secondary safety device that we offer. And I always tell folks too, because again, we just want to take a few minutes to make sure we're doing our part for safety. So just take a last look over your shoulder and make sure all the access covers are seated back on, and any secondary securing devices. So for example, we do have 2 self-tapping safety screws with our threaded lids over singular green, and often on the Tough Tights or the Polylocks, you've got 8 different non-standard head screws to engage. Make sure those are engaged. Just that, literally that 10 seconds to do that could really save a lot of aggravation, grief, and potential tragedy. And so we always just recommend people do that and remind people. All right, so we are running a little bit low on time. I do want to go over proper pumping as we wind up here. I do want to remind everyone that I hope this is the beginning of our journey. I am sorry I cannot be there live again, but it is for good reason. And rest assured, if you give me a call or send me an email or call any of my colleagues here at Norweco, we will get you the proper information, whether it's about our technology. I would stop here and also invite all of you to one of our monthly factory training schools. We do offer that. We've had it certified through IEHA for 7 continuing credit hours. This area is really, really fun, particularly from May until October. So if you're ever in the area or ever have plans or ever have interest in coming to our factory training, please do. You'll get a chance to see our continually expanding manufacturing facilities, get a chance to meet the entire team here at Norweco, and I think, last but not least, you'll obviously be able to come away with a nice certificate, as well as 7 continuing education hours that we're happy to offer all of you. So just as a reminder, you're all aware the Singular technology is not like a septic tank. So septic tanks perform a very limited amount of biological process treatment. So therefore, they're going to have to be pumped a lot more often than the Singular technology. I will point out too that in a properly operating Singular system, only the pretreatment chamber or chambers, actually only the pretreatment chamber will have to be evacuated. One of the things I also mentioned is that when you show up on site, make sure that aerator is running, because one of the first things you want to do when you remove that aerator after powering it down, and again, only after it's been operating for a couple minutes, is get a sample from aeration. Just set that aside, because our settable solids test is going to be a critical component of whether or not you're going to need to pump the system. Here's the reason why I say set it aside, and again, that's all you have to do. But you can see here, these are 3 separate samples from 3 different Singular systems that are very close to one another, actually here in Norwalk. And to the naked eye, right after they've been removed, you can see that they're really indistinguishable. However, when you look at after you've performed your service, which is going to be, anywhere from 20 to 30 minutes at the most, they are vastly different in terms of their overall volume. The one on the left there is at 10% in terms of the solids as compared to the overall volume and aeration. What that's going to indicate is a immature system, one that's been recently installed or recently pumped. No adjustments are needed, certainly no need to pump that system. The one in the middle is just between 55 and 60%. This is the sweet spot. Really anything between that 15 up to that 65, 70% indicates a very, very mature, very well-functioning system that's treating to a very high level. Certainly no adjustments needed and certainly no pumping would be required. But the one on the right there, that's at about 75, 80%. We are looking for a reading of less than 75%. All this means, though, is you failed the settleable solids test. It does not automatically mean that you have to pump. Now, I will always say pumping sometimes, when to pump, can sometimes be more of an art than a science. And if in a technician or other, qualified person, the system should be pumped, I would always defer to his or her opinion on that. But again, this is the best practice. So now we know in that third system there on the right, we have failed the settleable solids test. That means we have to undertake a pre-treatment chamber evaluation. Quite frankly, I would recommend doing this every time you're out at a system because it's very simple. First thing you're going to do is take a look at pre-treatment after opening that access lid and just seeing if there's anything in pre-treatment, excessive fats, oils, and grease, excessive non-biological material that can easily be dumped elsewhere with a little education that could just help the homeowner preserve and protect their investment a little bit more. If you have a good relationship with them, you can counsel on that. But no matter what, if you fail that settleable solids test, you also want to measure the depth of that floating scum layer and the depth of that settled sludge layer as well. So essentially, what you're going to do, we offer a hopper scraping tool, but take that or another straight edge. You're going to put that in pre-treatment. You're going to push that down until it gets through that floating scum mat. Turn it, a quarter inch or so, pull that out, see what the depth is. If it's over 10 inches, that's a good indication it is time to pump the pre-treatment chamber. You also want to check the depth of that settled sludge layer. So take a sludge judge, right, and you take it into pre-treatment, just wait till it hits the bottom, pull it out. If that's at greater than 38 inches, then that's also a good indication that you need to pump. Now again, I just want to reiterate that for our purposes, you only have to pump pre-treatment. However, there are cases where state or local law indicates you have to pump out the entire system. We certainly would push back on that, and certainly the recommendation would be not to do that absent other aggravating circumstances. But again, we always want to defer to state and local law as well. If you do need, let's just talk about pumping the system, right? So if you're just going to do the pre-treatment, you insert that suction hose into the pre-treatment chamber, then back it off a couple inches, obviously then activate that pump. Whether it's a singular concrete system or a singular green system, again, it's a very robust, very high quality tankage. Sometimes you can walk on pre-treatment, and so it's very hard to evacuate. In that case, you can backflush with water, you can break up that matter. Again, as long as you don't go overboard with that, the singular tankage, regardless of the material, is going to be up to the task. So if you need to break that up to evacuate it, go ahead and do that. Do not go nuts with pumping it either. If there's a little bit left at the bottom, that's okay. In fact, that material, both on the bottom and maybe on the side walls, is actually good, again, for a more efficient restart. Again, you can leave that there and then just refill pre-treatment. If there's ever an occasion or local state law or regulation dictates that you have to pump out the entire system, then remove the aerator, remove the biokinetic system carefully, set those aside, and you only are going to pump out of aeration. Never put a pump hose through the clarifier. Remember, there is a transfer port where that biostatic sludge return has that interplay. There's a transfer port between the clarifier and aeration. Everything will be evacuated out of clarification by virtue of that transfer port out of the aeration chamber. Now, very importantly, of course, never leave a singular or singular green system empty after pumping. If you do, you all know this. It doesn't matter if it's concrete, if it's high-density polyethylene, if it's steel, if it's fiberglass. This is a kind of thing that will await you if you do not refill that to the inlet with water for the system. So again, just want to remind everyone of that. So I just want to stop here. I want to thank all of you at the Illinois Environmental Health Association. I do look forward next year to doing this live, and I appreciate all of your understanding. Heather Anderson, I very much appreciate you being willing to work with me on this. One last time, I'm Brett Weber, Vice President of Treatment System Sales. Please give me a call at 419-668-4471 or shoot me an email anytime at bweber@norweco.com. Thank you all very much for your attention. I will look forward to chatting with all of you, hopefully very soon.
Okay, awesome. Thank you everyone for hanging tight for the presentation. I know it was a little bit longer than normal. I believe we will be able to get a copy of the slides and share that with everyone. I did put the invite code that he was talking about that's good for the month of March in the chat if anyone needs that. In the interest of time, I'm going to go ahead and turn things immediately over to James Meese. James, are you there?
Yep, I'm right here.
Excellent. James, whenever you are ready, you can go ahead and share your slides. James is going to be talking to us today about, and James, correct me if I'm wrong, resolving wastewater treatment challenges in small communities.
Yep.
Excellent.
All right, so we will begin. Okay, so this is resolving wastewater treatment challenges in small communities. To begin with, I do need to acknowledge that this project has been funded wholly in part by the United States Environmental Protection Agency under a training and technical assistance agreement with Rural Community Assistance Partnership. Basically, this is just our disclaimer. I will also say that these slides are a partnership between RCAP and NORA, the National On-Site Wastewater Recycling Association. So through our partnership, we were able to create this program and offer this information. Here you can see my information. I have my email there and my phone number. If you have any questions or need anything after this, feel free to reach out to me. RCAP is part of a regional organization. We do have 5 regions. I am based out of the Great Lakes region, which consists of Illinois, Wisconsin, Michigan, Indiana, Kentucky, Ohio, and West Virginia. So we do offer all these services in those states. So if you do have colleagues in other states that you think could benefit from RCAP services, feel free to reach out and I can connect you with them. We also are in all the other states as well, but specifically I'm based out of the Great Lakes region. So the mission of RCAP is to improve public health, surface water protection, environmental compliance, economic readiness, and quality of life in small communities and rural areas. We offer access to funding for water and sewer projects, both on the smaller side for communities and we can even help individual homeowners. Improve the capabilities of water and sewer projects and promote shared services and regionalization projects. So that's kind of what we're all about. See, and you can see here, this is just kind of a list of our basic services. The ones that would be, I think, most interesting to you would be our private well program and our septic programs. What these are is we can help individual homeowners with private well and septic assessments. What we will do is we will come out, we will assist them with any questions they may have, and we will also offer free well test and have a full septic inspection for them. They'll get it in a report and sent to them while we are done. These are other services that we can offer smaller towns. So for instance, if you have an area that is completely on septic or well, and they're looking into putting a water treatment system or sewer system in, we can go in there, we can help them kind of develop what that plan would be, and we can help them find funding and access to it as well, along with all our other services here. So jumping into the evolution of an on-site wastewater treatment management, kind of see where it's going, and you can see that a lot of these challenges and all the information does pertain to individual homeowners, but it can also pertain to smaller sewer systems as well as they kind of move forward. So our learning objectives today is we're going to describe what wastewater management goals, we're going to define system functions, relative to each management goal. We're going to define system management relative to each management goal. We're going to describe reactive and proactive maintenance. And we're going to list drivers for change and management goals. So our overview here is an evolution of wastewater management goals. The definition, we're going to look at what is the definition of a functioning system. We all kind of know what that idea is. Of the idea of functioning, it can be defined as, a number of different ways. So what is a functioning system? What is the protection of a public health and safety? Again, we're all here to protect public health and safety, and how are we going to be able to do that? And the protection of environmental health and safety in those water resources. Water resources, as we all know, is one of the most important things that we have. A lot of people don't always realize that that's both on the water and the wastewater side. Those wastewater resources are almost just as important as the water to the health and safety of our clean drinking water. We're going to look at the evolution of system management, reactive maintenance evolving to proactive maintenance. Goals evolve based upon drivers for change, and education is critical to help with these management goals. So what are the ends of the spectrum for management goals? We have outdoor plumbing all the way down to water reuse. So what are we looking to do within that? Are we looking just to offer outdoor plumbing? Are we going to full water reuse to a fully functional system, or kind of somewhere in between? Everyone is somewhere on this spectrum that I think we can agree with. And as we kind of move forward to that, and to have the most effective wastewater systems for communities and individuals, what do we need to know? What education do they need to know? Do they need to know, what management? They need to identify the current status and the identification of potential drives for change. So looking at, outdoor plumbing, the pit of privy, the goal is, designated place for waste. That's it. This is kind of, your most basic forms of wastewater management, and kind of the way for the longest time that things were looked at. There's no carrier needed to convey waste. You are just collecting the waste and not even treating it. You're applying it directly to the soil. The public health concerns are addressed through isolation of the waste, but they have nothing, we're not doing anything to treat that waste or anything. The public health concerns are very high. And the idea is, you're going to relocate it when full. I mean, very rarely do we see this, but we do see it in some communities every now and then. Individuals' campgrounds can kind of sometimes be one there. Indoor plumbing. So this is, the goal is to keep everything flushing, to keep everything working. The water carrier is conveyed the waste out of the facility. You do have a collection system, either on site or a bigger wastewater system. There is a hybrid called a cluster system now as well, which we will kind of go over later, which is basically a decentralized wastewater system, where essentially you are combining wastewater systems into a community. So instead of one individual having a septic or wastewater removal system on their property, we're kind of combining that, but we're not doing a full wastewater treatment plant. The public health and pathogens, it does remove waste from the facility, and the management is just to keep that pipe flowing and to keep everything going. Some surface disposal, the goal is to limit human contact. Again, kind of burying that waste. We're trying to keep that waste below ground, typically cesspools, which would be here, or deep injection of all waste. We don't see a lot of this in the state of Illinois, but they are out there. Public health is disposing of pathogens. Treatment is kind of hard, and the management is install, flush, and forget, and there goes. Solid capture and subsurface disposal. The goal is to limit human contact, is to keep wastewater below ground. Our disposal options, again, are kind of limited. For public health, it's disposing of the pathogens, and the treatment is to add a septic tank to capture suspended soils. Management, install, flush, and forget. This is going to be the most common one that we see, again, among homeowners who are on septic, and kind of it is really the kind of the basic of wastewater systems as well, just on a bigger form. Septic tank and soil treatment area. It's an evolving goal. It's the disposal of effluent goes away. A dispersal, the contaminant treatment, public health and environmental issues are addressed within that, as long as they're maintained properly and doing all the proper maintenance that can be done, which we know can be kind of overwhelming on occasion to homeowners. The management is disposal, often none at all. And the dispersal system management is critical for that dispersal. As you can kind of see here, you want to make sure that aerobic soil is there. You want to make sure it's packed, but not packed too tightly, so that effluent is able to go kind of disperse within to that ground and trickle down to make sure that it is kind of being treated as it kind of naturally goes back into the water source and the water table. And again, this kind of goes back to, again, how bigger wastewater systems, especially in the smaller communities, because while some do have wastewater systems, they are going to be much smaller than your larger community water system. So they do take a little bit more work on occasion to upkeep, especially both financially and with the maintenance. So our goal for treatment and dispersal, the goal is now dispersal. So looking at the hydraulic cycle, starting to address both environmental concerns in addition to public health concerns. I mean, those kind of go hand in hand, one and together, but they are in separate categories. Those environmental concerns, how can it affect the environment around us? How can it affect what's happening? All the way down to the public health concerns. How do we make sure that we are disposing of waste in a proper way to make sure that people are not sick, and it's not affecting their clean drinking water, and overall, nothing is going to happen to them. Technology advances now allow for the removal of pathogens, solids, and nutrients. Again, I think this technology is constantly evolving. I think we just saw a presentation on that as well, showing that the evolution of this is going quite quickly. So kind of staying up on it is important. But at the end of the day, the most important thing we can see is system maintenance. That's going to be the most important things that homeowners and sewer systems can do, is making sure that that system is being properly maintained, that the wastewater is being properly treated, and disposal and dispersal is happening on a proper level. And I think once those things start to have an issue, or if we start to go south on any of those, that is when we can kind of get into trouble. So looking at this is for on-site wastewater treatment systems in the hydraulic cycle. Just kind of seeing, the real basics here, how it's spelled out, where the flow is, where the runoff is, and just making sure that you're being aware of this and cognizant of it while you're looking at wastewater treatment systems, while making sure your placement is, making sure that everything is maintained, because at the end of the day, they are part of a much bigger system within the water system, and they are key to public health and safety. So now we're talking about water reuse, kind of a more evolved idea of we're not just disposing of waste anymore. We are actually going through and figuring out, hey, can we use this water? How can we treat this water so it can become reusable? We can look at outdoor water reuse. Can we treat the water to the point where it can it can be used for landscape, or for crops, or for aquifer injection? We want to make sure that process monitoring is done, to make sure that we are both having the most effective process with it and the cleanest process as well, making sure that everything is being treated, everything is happening in a way where we are getting the maximum value out of our on-site wastewater treatment systems, and also making sure that we are treating as much as possible to get those pathogens out. We want to look at troubleshooting is critical. Again, if there's any sort of failure in this, it can cause much bigger problems, leaking or things not being treated, especially when we're talking about water reuse, if we're actually using this water over and over again, as opposed to just treating it and getting rid of it. So once we kind of go beyond that, that is really when troubleshooting and maintenance becomes the most important thing. And management is critical for protection of the public health and environment. Again, back to what I was saying, we want to make sure that everything is working properly for this, so that it's critical for everyone to be safe especially when we're using water reuse. Again, looking at water reuse, the goal is careful use of valuable resource. We're getting to the point where we can no longer just disperse of this wastewater. We need to be able to reuse it. We need to be able to make sure that it can go back into the water system clean and properly, and that this water is being used to its maximum effect. There are non-potable uses for it. So indoor water reuses. You could reuse it in your bathroom, urinal flushing. If it's treated enough properly, we can look at clothes washing as well. To use that to be able to do our laundry and make sure that we have that, clean and possible. We are reusing that water, but we are not consuming it. Pathogen protection, a detection through testing is reactive criteria. It's too late. So we want to make sure that we are doing everything ahead of time. If we start suspecting pathogens, it might be too late to be able to go back and see what we were doing, especially with the water reuse. So we want to be able to get ahead of this. Validate treatment process, operational status to limit risk. Again, we want to be able to make sure as we're going through this process, if we're working into water reuse, that the treatment process is validated, that everything is working properly and perfectly before we really start going through it. As far as the management goes, we want to make sure that the process monitoring is critical. We want to make sure that that process is going through. Again, that no functional breakdowns will happen within it, and that nothing will become, there are no issues within it kind of moving forward, because again, that is critical to the entire system. And we want to make sure remote continuous process monitoring keeps system running. Again, that is how we make sure that everything is running clean, properly, and effectively, is through that system monitoring and making sure that everything is happening to the maximum ability. Talking about system management. So, we've kind of talked about what we can do with the systems, but how do we manage them? As I had spoken to earlier, this is the most critical core to these on-site wastewater receptacle systems, is what do we need to do to make sure they're running efficiently, properly, and to protect the environmental and the public health. So we want to make sure the system's functionality. Is it functional? Is it the right type of system for the goal that we are trying to do? Do we need to look at septic? Do we need to look at, a bigger idea of maybe a private sewer or a sewer system, a much larger one? Or do we need to start kind of thinking about one of those cluster decentralized systems again? If you have a rural area that's kind of growing, have we outgrown the basic septic? And if so, what needs to happen so that the residents of that area are, effectively getting everything they can for their waste disposal? We want to make sure operations are up to date as well. We want to make sure we're operating at maximum level, that operations are efficient, both efficient in the way that we want to make sure that the water is disposable, but we also have to look at cost affordability here. We know that building a new both septic system within a house, or even looking at a wastewater treatment plant, can be very expensive and daunting. And that when we kind of discuss this idea with homeowners and cities and communities, we want to be aware that the operations are very important, and that the effect of those operations, both financially and on the health side, are major decisions for individuals. Maintenance, again, we want to make sure that maintenance is proper. We want to make sure that that maintenance is up to date, that we are doing it proactively, that we are monitoring everything we possibly can as efficiently as we can as well. With the new technologies coming out, monitoring them has become easier and more advanced than it ever has before. We are no longer just kind of seeing what it can do. We can see what's happening in real time. We can see what needs to be fixed, and we can find if there is a system failure it quicker than ever before. And then we can also come up with that solution for that system failure to both save the homeowner or the wastewater treatment plant money, but also to avoid a much bigger public health issue. And then again, we need to kind of decide when system replacement may be necessary whenever we hit critical failure and repairs are no longer there. If we are getting close to that idea of maximum capacity and critical failure, what do we need to do to start planning for the future of that, and where do we need to begin? On my previous slide, one of my slides earlier, I had spoken to RCAP does asset management. We do that for water and wastewater systems, but honestly, we can also do it for individual homeowners as well. And I think it's something that individual homeowners need to be made aware of is they own the asset. The septic system is an asset and part of their household. Part of the second part of that asset management is the word management there. So what do they need to be managing it? What money do they need to be putting back to save it? Or what repairs do they need to be do? Where are they at with it? And within that, what needs to be done for them to be able to save money? So when that, so if we do come up with a critical failure or we do have any issues, how can we quickly solve that? Because it's not something that you can go without. So the evolution of operation, maintenance, and monitoring. Operation, evaluating system components for operational status. Again, kind of going back to that idea of asset management. What needs to be evaluated? How do we need to be evaluating it? And what can be done to make sure we're doing it efficiently? Using checklists to evaluate components. Going out with a simple checklist, providing the homeowners with a checklist to see what exactly they have within the system, making sure they're not missing any critical parts or anything has failed within it. So they can quickly do a yearly or bi-yearly inspection to make sure that their system's running properly and they don't need to start saving or getting ready for anything. I'm recording and evaluating data for troubleshooting component status. Again, making sure that they're collecting the right data, that they have the data and they understand what it means. So when they do need to look at it, they can see if there's a trend going one way or the other and to make sure that they're looking at maximum efficiency. Process monitoring and adjustment. Helping them understand what the process is within the wastewater system, helping them understand how there could be adjustments both seasonally, based on drought as well, kind of letting them know that adjustments need to be made to that process, but most importantly, we need to be monitoring that process so we are effectively doing everything possible. And then analyzing component operational data to predict future malfunction. This kind of builds on the other 3 points that we there on that slide. Is now that they have the data, they know what they need to be doing. They know how to look at it. So how do we analyze this to make sure that the data is there to be able to help predict future malfunction? So one, we can both jump on it when that malfunction does happen, and two, how we can start saving for it financially just in case there is a problem there in the future. Looking at maintenance, cleaning, adjustment, and replacement, periodic pumping for solid removal. I have found that doing both well and septic assessments throughout the state of Illinois, that individual homeowners are all over the place where their pumping is. Some will do it every year, some will do it every 3 years. I have some who have made it over a decade without pumping their septic system. So, letting individuals know the importance of pumping and to make sure that they are doing that and their solid removal. We always suggest having at least someone come out once a year or at least every 2 years to do a septic inspection to help them with all these things that we're talking about to maximize their operation and for the maintenance. Parts changing only. Again, we want to make sure that they have the correct parts on there, the best parts that they are, and the most efficient parts. So we're running them most effectively. Routine maintenance activities. We want to make sure that those routine maintenance activities are being done and that those routine maintenance activities are being scheduled as well. Part of having the system is the maintenance of it. It's like anything else. So even a larger scale of a large sewer treatment system or an individual homeowner with a septic tank, having that routine maintenance, doing those inspections is the most important thing you can do. And then also the replacement of component parts making sure that if anything breaks, we're not just letting it go because we don't, find it important, or we fixed it, but we haven't fixed it to its maximum capability. It's barely hanging on. So we want to make sure to stress that those replacements of those components are important and that they need to be working to functionally operate the sewer treatment system. We also want to look at monitoring parameters, testing, and system components. We want to look at the diagnostic versus the performance evaluations as well. Doing the diagnostic tests to see kind of how everything is working, but also based on performance as well. Are we getting the maximum performance, and are we getting the performance that makes everyone feel comfortable with that system, so that they are getting clean and efficient drinking water and wastewater, and we are treating it properly so it does not affect our drinking water. So we want to look at reactive versus proactive maintenance, as I'm sure you all are aware, that these are vastly different ideas, and that looking at the proactive maintenance will ultimately save you a lot of work and time. Will also help you avoid critical failure much easier than doing the reactive maintenance as well, and really stressing this with homeowners so they're aware of the process. So reactive maintenance service visits, you fix some malfunctioning components. So you have found that there is a malfunctioning component, but you've only found it being reactive now that it's not working or it's broken. And it might have been failing honestly for some period of time. It has ultimately hit critical failure at this point, as opposed to be as instead of looking at it and seeing what could have been done before. Or you replace broken pumps, compression, or plumbing back up in the house. I mean, this is going to be your most obvious that you are that there is an issue, and we're reacting to it by seeing what can be done. But ultimately, we've already hit critical failure when we've hit that point. And again, we might have had massive failures happen before, and damage could have already been done at this point. As opposed to looking at proactive maintenance services, it's performing routine maintenance on components to extend compound's life, making sure that we're doing that routine maintenance, that they're running to their maximum capability, making sure that they're coming out and we're working with them as efficiently and quickly as possible. We want to repair mechanical components before catastrophic malfunction. Again, we're doing that asset management side that I kind of spoke to earlier. We are looking at the assets and we're managing them to see what their extended life is. We have hopefully been saving financially and making sure that we have the parts in place. So if that catastrophic malfunction is close to happening, we'll replace it before it does. We want to replace components before degradation and effluent quality. Again, we want to make sure that this happens once we do start affecting that effluent, and there isn't a major effect on it. It does become hard to kind of reel it back in. It will take several steps until we are effectively running on it as much as possible. So we want to be proactive in that maintenance to make sure that everything is happening perfectly, so we don't have to take several steps to fix any sort of failures. And we want to repair or replace components before malfunction. Again, most important thing that we can do is looking at those assets, that we're managing them, that we have them, we're repairing and replacing the components as they're getting close to the end of their useful life, as opposed to after the end of their useful life. We understand that this is a major step for individuals and small wastewater systems, but at the same time, we want to make sure that we are able to have that capacity and the maximum functionality. So looking at reactive maintenance, system pumping, not able to flush, obviously one of the biggest ones. So you have your flooded systems, or you could have major pumping problems within there. Essentially, you're not able to dispose of your waste. Servicing wastewater in the landscape, that could be a potential for a leak or any other issues, and pumping tanks to remove liquid and solids. So kind of seeing, those are some of the pumping issues that we may run into. Looking at replacing parts, malfunction equipment, parts changer. what are the parts being done. We want to replace malfunctioning parts. No troubleshooting to identify root cause of the malfunction. So we haven't, with that would be reactive. We are seeing that there is a problem and that there is a malfunction, but we need to start looking at what is the cause of this malfunction, and is it tied into a much larger issue, or is it simply a part malfunctioned? This could be due to aging infrastructure, overuse, or environmental changes within the area. So kind of thinking about this idea is, if we do have an issue, we can simply fix it, but we also need to diagnose the problem of where the critical failure came from. Servicing wastewater in the landscape. Again, we can replace the disposal fields, and that while that is useful, we also need to look at what needs to be done to the soil, what needs to be done so this isn't an issue in the future. And we need to be proactive about that. It is possible to have reactive maintenance at first, but then ultimately start planning for that proactive maintenance as we kind of move forward with it, making sure that we're doing everything possible so that maintenance is being done, and we're doing everything we can to protect our water and water treatment systems and our assets moving forward within both homes and small systems. The philosophy of reactive maintenance. So owners' expectations are contract service providers to respond to the problem. And this is true. I mean, if you have that and you are being reactive, you will be able to hopefully get a service provider to respond to the problem. Hopefully you don't have any issues in the middle of the night, or it's not a critical failure that is really starting to affect your system, because obviously that is going to be a problem. Kind of as opposed to, if you are proactive within that and you're able to kind of plan for that and get on a schedule to make sure that they're coming when you need them. Owner expects a big bill when the service provider is contacted. That's how we had discussed that once you hit that critical failure, it can become much larger and more expensive for both homeowners and treatment systems, as opposed to doing maintenance over time and having much smaller bills that will give you a more effective system. And it limits contact with the service provider as well. You'll only see the service provider when things break, but you need to have contact with them so they can come out and do that proactive maintenance, so they can see what exactly is being done and what services they recommend, as opposed to reacting to it and just having them come out when everything is broken. Service provider expectations, they only arise at the site during extreme malfunctions. Again, they are coming when everything is broken and we've hit critical failure, but we need to kind of work with them so they can start coming out and helping us diagnose issues within the problem. Service providers changes the blown engine of the day, but again, that we need to go back and kind of look at, well, if that engine blew, what is there an overall bigger cause? Are we using more? Are we treating more wastewater than usual? Is the system having an issue with it? What exactly is being done to do that? Considering fixing disasters as great money, and while they are as one larger paycheck, it is actually more valuable to both the service provider and individual homeowners to do this routine maintenance, and to get on a schedule and be able over time to make sure that we're maximizing those wastewater treatment systems. And the idea is that, homeowners will think that they have no interest in identifying and fixing the real problem, but that is simply not true. Most service providers will work with you to help identify what your problems are, help maximize the idea, and really help with those critical infrastructure to make sure that we are efficiently getting everything we need. Looking at proactive maintenance, we want to perform routine maintenance. Making sure that we, like I said, homeowners or small wastewater treatment systems are on a routine schedule for someone to come out and do exactly what maintenance needs to be done, to make sure that we are maximizing that, we're managing that asset properly. We want to troubleshoot system malfunctions. So if some of the things are starting to malfunction, can we make a few simple, easier changes to them to make sure that those systems are easily starting to run more efficiently. Data collection at site and service provider evaluations. again, we want to make sure that we're having that critical data. We are collecting it. We're analyzing it and using it to its most effective value. So individuals are able to kind of understand what it is and what we can do with it and what it's really telling us. We want to look at telemetry or remote communication and alarm statuses. We want to make sure that we have that remote communication and alarms in place just in case there are any issues, if we are away from the wastewater system, if we have seasonal households, or if you're a small wastewater treatment plant and you don't have an operator on staff at all times, to make sure that that is happening and those evaluations are taking place, and we're doing everything we can to catch those emergencies early so we can both protect the environmental public health and protect the assets themselves. And we want to have remote continuous process monitoring as well. Like I said, as the technology has evolved and things have gotten better, we want to make sure that continued process monitoring is happening, that we have everything in place for them, and that we're doing everything possible to make sure that that is going through, that monitoring is taking place, and that we're doing everything within its power to be able to do that. So proactive maintenance, we want to perform routine maintenance. Does routine maintenance extend the life of the system components? The answer to that is obviously yes. Having that routine maintenance, making sure that we're maintaining it, making sure that we are doing everything to the manufacturer's guidelines as well, looking at those guidelines, making sure that things are being changed out, rested, greased if needed to be, will obviously extend the the life of the asset. The example here is an engine. Do you need to add or change oil with a combustion engine? Or do you just replace the blowing engine? So, a lot of times we compare our assets to cars, which are an asset, but making sure, with a car, obviously routine maintenance is being done. Oil changes need to be done. Tires need to be changed every couple years to continue the life of that asset, and making sure we're extending it and running it as efficiently as possible so we can avoid an emergency replacement if needed. So yes, performing routine maintenance on components extends the component's life. Examples of routine maintenance are cleaning pump intake screens, make it simple, real simple fix there, making sure coming out, cleaning off those intake screens on septic systems to make sure that that's being done, to make sure that everything is getting through and flowing properly. Cleaning and replacing air filters, again, a really simple fix and a really simple piece of maintenance that will extend your life of your system dramatically and avoid any sort of critical failures if there are any issues. Cleaning drip filters, making sure having a service technician come out, checking all these filters, doing any sort of cleaning if possible, and also learning about how you can potentially do it yourself. Removing of sludge from dosing tanks. Again, doing that sludge removal is vital. Having it done every couple years, or at least having a service provider come out and tell you if it needs to be done. Understanding what your sludge level is, and understanding that that sludge level does need to be adjusted and fixed as we kind of move forward. Replacing riser lids, making sure that those lids are safe, making sure that everything is sealed, making sure that there is no leaks within it and there are no threats to anyone. And pumping biomass and sludge from the on-site wastewater treatment systems. Again, this is both true in bigger systems and smaller systems, that if you do have any sludge or a sludge system, we want to make sure that that sludge is being pumped or treated properly, and that is being taken care of and disposed of properly as well. This can create real issues, especially if there's a backup. This is one of the most common things that will lead to critical failure. Proactive maintenance troubleshooting as a part of business. So performs a root cause analysis of the malfunctions. Again, or back to what we were saying, is not only just seeing what the malfunction is, but is there a much larger problem with the malfunction? Do we need to start reevaluating how our system is running and what needs to be done to maximize it? Or is it just a simple failure and we can do everything we can to fix it as well? So fixing the real problem when replacing components. Much larger time, everything in these systems is built together. So if there's stress or critical stress on one or another, what can be done to make sure that that critical stress is being taken care of, making sure that we're doing everything we can to look into these and making sure that we're doing everything we can do that, making sure we can do everything we can to maximize the asset. And we want to reduce the risk of having future malfunctions resulting from the same problem. If something is broken and it's starting to malfunction, is it going to keep happening, or is it something that we can do to adjust the factors so it will not continue to break and not continue to have issues? And we can offer a total solution to both owners of on-site wastewater receptacle systems, or we can do it for owners of small treatment plants as well. But basically, looking at the everything from a bigger view, if we zoom out a little bit, we can kind of starting to see that a lot of these problems build on each other, and what do we need to do to make sure that we are doing everything we can, especially if we have an aging system. What needs to be done so we can maximize the system and continue to have it running well into the future, as opposed to reacting to it and having to put in a new system, which will cost a significant amount of money. Or we can do some small maintenance changes to make sure that we can continue to use it as functionally as possible. So proactive maintenance troubleshooting examples. Pump screens plugged result in excessive pump wear and decreased life expectancy. So here we can see the simply making sure that that pump screen is cleaned and making sure it's there will help extend the life of your pump. We are not going to do excessive pumping. That pump is not turning on and off on a regular basis. It is just pumping what needs to be done, as opposed to the excessive pumping to be able to get it through the screen. Hydraulic overload washes solids through the system due to leaking lids and risers. Again, so making sure that, if there's any leaks in there, if we have any lids and risers, making sure that those are sealed properly. So it's a simple fix that looks in the life of your pump and your overall system as well. We want to make sure seal risers, replace lids, and offers an effluent screen to assist in retaining solids in the septic tank. Again, we don't want any leaks coming out of here. Ultimately, we want everything sealed within the system until the effluent is ready to go back out into a drainage system. So we want to make sure that we are retaining it. We have that systems within there, and we're doing everything we can to keep that in, one, for our own health and safety, and two, to avoid any sort of major issues with over pumping, over leaking, and overall excess stress on the system. Filter plugging results in long pump run times. It identifies solids in dosing tanks and issues causing plug filters. So this kind of goes back to the idea of, so we know that we're having an issue with our pump that is clogging. So looking at our screen and it's being clogged. So looking at the idea of what is causing the screen to clog. Is there an issue with the solids? Are we not properly maintaining the solids? Are things being put down there that are not supposed to be going down into the wastewater system? Having a conversation with the homeowner to help educate them on what needs to be going into their system and how to best use to avoid this overall problem. So we have identified that we are having an issue with the screen being clogged, but now we're looking at what is actually causing those clogs. And if we can identify that, we can help identify any plugs or anything happening moving forward will cause that to not happen. And we also want to identify if solids carryover is hydraulic or organic overloading. So again, kind of looking at where are those solids coming from? What are they? What are we doing to cause, if there's anything to cause that overload? And what is happening with them. So again, proactive maintenance, recording operational data. I think this is something that's more important than ever, especially with the ease of which it's becoming available. And making sure that we are collecting that data and understanding it. So systems operational data, we want to look at air pressure, pump runtime, and pump dose. Again, looking at that pump runtime, is it running an unusual amount? Is it running an average amount? If it is running very high, what needs to be done to figure out why it is? Is it a leak? Is it a clogged screen? Is it a simple fix? Or is it something much larger? And what can be done? Tracking the data with time, are data values changing, increasing or decreasing operational values? Again, if we are both seeing an increase in pump time or a decrease, why is that? Why is that pump not, running as much? Again, is that a cause of an overall problem? Is it just a decrease in the amount of use, or is the pump not maintaining itself and is it malfunctioning properly? We want to evaluate changes in deviations. Again, if there are deviations, why, if they're there and they're typical, that's great. If those start to change, has something within the system changed, or individuals' routines, and if so, what do we need to do to figure out what's happening, and how do we adjust to our new routines to make sure that we're running everything properly? We want to make sure if there are anything outside the normal or expected range, we want to identify why that might be happening. Is it a one-off event? Is it something that's happening on a regular basis? And if so, what's going on? Extreme changes in values, pump runtime especially. Again, why is that pump running? That is usually a sign of a much larger overall problem. So we want to make sure that those values are important and we have there. And an unexplained decrease in values, cycles per day. Again, if those values are going down, if we're looking at those cycles and they're not lasting as much or they're not happening as frequently, we want to be able to help identify what the issue is and what we are doing to solve it. So here, this is kind of an example of looking at data, and seeing the increased air pressure over the last 4 months. We see it pretty consistently. Then we can see here the alarm went off once the diffuser was replaced. Obviously, that dropped. So as you can kind of see, that the air pressure over the last couple months had been increasing over a period of time. So this was not just a simple, easy malfunction to break. It had something that had been happening, and if that high pressure alarm had not gone off, we would have continued to kind of have an issue with it. So kind of going back to what I was saying, that a lot of times these malfunctions are not something that happens simply easily, or it's not a one-off of something breaking. It is an overall condition of a much larger maintenance issue. Looking at telematics, combine telecommunication with record system data stored by receiving entity associated with the control system. Track system components operating parameters. They want to look at the pressure, electrical runtime, and dose frequency. We want to look at the record components, the operational data, and the alarm conditions are communicated to specified individual owners or the service provider, letting them know why did the alarm go off, what happened for it to go off, and if it had been going off, what is that and what is the issue? And again, just kind of a classic example of the telematics here, seeing all the data on there and what it can do and what it can show. So process monitoring with the telematics, we want to combine telecommunication with recording of system data. So we want to have that system data with the telecommunication that is providing it for us. We want to make sure the data is stored by receiving by someone, either the homeowner or the operators of the sewer system. We want to track the system component operation parameters to make sure we are properly doing everything and everything is running at the maximum capacity. We want to make sure pressure, electrical runtime, and dose frequency, et cetera, stays consistent. The telematics will help us provide that information. And we want to record component operation data for evaluation. That will tell us if we are having a problem or if we're running towards critical failure or not. And we also want to, the alarm conditions are communicated to individuals who would be interested within that. Process monitoring with data analysis. We want to analyze component operation data to predict a future component malfunction. This goes back into the asset management that we had discussed earlier, making sure that we have those assets and we are making sure that there's not a clear critical failure coming. We can do comparisons with these. We can identify trends with them to see if we are having a problem, if we're coming near critical failure. We can also operate the parameters outside of the normal range and any anomalies in there and figure out what has happened with the anomalies and if we need to do anything to adjust if those are becoming part of a normal routine. Again, looking here, this kind of showing how all this speaks together and how all this data is here. It lets you know kind of, where are we doing, what are we building, and the data will show you that we are getting closer to a problem. Again, this one's water infiltration, kind of a great example. Showing, if that infiltration of those rain events do increase, what is happening within our system, and is it showing that we have a sign of a much larger problem? Looking at remote continuous process monitoring, again, how do we monitor those processes if we're not there? We want to make sure that those access and continuously analyze system operation data, even if we are going to be remote, or making sure that we're looking at it. Early warning systems regarding component malfunction, we want to make sure we have those. That data will help us show that if we're getting close to that malfunction or failure. Repair mechanical components before catastrophic system malfunction. Replace components before degradation and effluent quality. And we can also help, can reduce the risk of public health issues when implementing water reuse systems. So again, these will help kind of understand that and make sure that we're doing everything we possibly can to avoid any public health emergencies. Again, going back to the philosophy of it, we want to make sure that if we do have any alarms or provide any service providers, we want to make sure the owner expects troubleshooting of the system to identify a cause of malfunction. And we want to make sure that the views of service providers are part of management team for proper function. So this talking about, your drivers of change here that are kind of going back into this philosophy, limited water resources, environmental concerns. We also want to make sure we're protecting the infrastructure investment in the water and wastewater, landscaping, property values, tax bases within that. And I would also say just the overall cost of what it is now to maintain a wastewater treatment plant are kind of driving this idea that we need to protect what we have, and that we need to do everything we can to make sure everything's running efficiently and at maximum value. Looking at management goals, we're looking at our design requirements. Do we have the best possible design? Our treatment and dispersal components, are we doing everything we can for our treatment? Do we have the best possible treatment? System operation, maintenance, and monitoring requirements. Are we doing everything we can to monitor them? As we had talked about, the advancements in technologies are making this the most important, easier and more important than ever possible. So, summary of the evolution of wastewater management goals. We've looked at what a functioning system is. We understand public health. We understand the safety, and the goals based upon drivers for change. So that is what I have for everybody. So I'd like to thank everybody for joining me. If you have any questions, if I can provide any information, feel free to reach out. I shared my contact information on the first slide, but I'm sure it can be provided to you. And if you think that RCAP can help you or anyone in any way possible, please let me know. Thank you, everybody.
Thank you so much, James, for your presentation. And thank you all so much for hanging tight since we're a little over. I'm going to go ahead and shift this over to Lenore to close us out for today before we talk about next week.
Well, thank you all for joining us, and what a great presentation all of them were. I would remind you to please fill out your evaluation forms. That's very important as we work to try to improve things always. And also, you will need to submit your CEU forms to Heather in order to obtain CEU credit. So thank you all.
All right. And thank you, everyone. We'll see everyone next week, Tuesday, 1 p.m. for our next set of presenters. Hope everyone has a wonderful weekend and see you then. Bye.
Bye.